Hi, Danko.
Hey, do you hear me?
Yes, I do.
Very
Danko, we
good.
are live, and really apologies for the inconvenience being caused. There has been a lot of network glitches. So, without wasting any much of time, we have like 100 plus people who have already joined in. So, let's just start with the next session. So, Danko would request you to take up the stage, and people who have already joined in. So, let's just yeah, start. Sorry. So, we can just start with the session. I see you are on mute.
Do you hear me now?
Yes, it's audible.
And do you see my screen?
Yes, I see your screen. I just did added it to the streaming.
All right, very good. So I will
Great.
start just
Yeah.
now. Okay, very good. Thank you for inviting me. Of course, it's a pity that we have technical problems, but that's normal. If you want to be on the edge of technology, sometimes you will fall off the edge, but then you climb back and then you're again back on the edge. So let me say a few things about me first. I have been, for the most part of my life, a brain scientist, a neuroscientist, a cognitive scientist. I have artificial intelligence under my skin deeply, even since before I started doing neuroscience. But it's very important to understand my profile, so because you will understand my talk then better, where my talk is coming from. Right? Now, the topic of my talk is has to do with the future of intelligence. It has to do also with the limits of intelligence. I think there was a slight miscommunication about what exactly I will talk about, but only a slight. So I think it will be pretty clear what is happening here. Now, let me start with this guy. Imagine you walk one evening in a park and you meet this guy. You meet an alien coming from another planet, and he's friendly. He's talking to you, and he starts talking some stuff, right? And explaining things. And you question, like, what the hell is going on? And your immediate thought about the relationship between you and him will be something like this. You will think, oh, he must be much, much, much smarter than us. After all, he made it to the planet Earth. We didn't make it to his planet. So our human intelligence must be much smaller than his intelligence. But what if I tell you that the situation is likely somewhat different? The situation may be something like that. Yes, they may be more intelligent, they may have more tech and math and science because they made it to our planet. We didn't make it to their planet. However, their intelligence may be different than our intelligence. There could be some overlap. Sure, there's always some overlap. But stuff that we know, although it's less stuff, we may know only us. They may not know that. They may not have Pythagoras theorem at all, and yet they may have some other things. Right? Now, this side of type of perspective is very uncommon. You don't find it in science fiction, but it's very important. It's very important if you look at, let's say, relationship between us and animals. We have our own intelligence. We have our own stuff. On the other side, you have an ant. Is it possible that an ant have some intelligent stuff that we don't, that they are in some ways smarter than us? Now, why is that important to ask this question? Of course, it's because of the robots. That's what we are talking about, AI. Are the robots of the future going to be smart like humans, or are they going to develop in some other direction, like that, not like maybe smarter than us, but not smart like us? So let's explain this again with Venn diagrams. Now that's how we see typically the situation today. Human intelligence is bigger than artificial intelligence, and AI is like a small subset of what we can do. And then we hope that in the future this will happen, that somehow, say 20 years from now, artificial intelligence will kind of more or less cover human intelligence. And then afterwards, maybe in another 20 years, it will just completely expand and it will be much smarter than us, exactly like this alien that I was talking about. But what if I tell you it's all wrong? It's not. That's science fiction, but it's not science. So science of intelligence tell us that something else is possible. So how about that today? Artificial intelligence is smaller than ours. It has a smaller Venn diagram, but it also, there's only an overlap about the intelligence, and machines can do stuff that we cannot do. They're intelligent in ways we humans are not. Now, this means that it's a relatively easy task to develop this intelligence further, to grow AI in the direction away from human intelligence, some other intelligence space. And the hard problem is actually to pull AI into the direction of humans. If we want AI to take human tasks, then we have to pull it in the direction of human intelligence. And that's the hard one. And that's what I want to talk about. And I'll talk about 6 problems that we have in pulling human intelligence into the direction of pulling AI into the direction of human intelligence. So problem number 1, we do not know how the brain works. Well, I think this is pretty straightforward. There has been lots of brain research. There has been lots of money spent on brain research and lots of papers, lots of theories, lots of explanations. But if we are honest, as a brain scientist, and I'm telling you as an insider of a brain science, we don't know how the brain works. We know lots of details, lots of basic things, lots of elements, but we don't know how the whole thing brings together human intelligence, how the brain creates the mind. We simply don't know. We have lots of ideas, lots of theories, but we pretty much know that all of them are wrong. We still did not get the right one. So the situation today in a brain science is like situation in understanding the variety of species in the biological world before Darwin, or understanding the relationship between mass, energy, time, travel of speed, and so on before Einstein's theories of relativity. That's the situation right now. We don't know what's going on. That's really hard to develop AI if you don't know how AI that goes in the direction of human brain, if you don't know how the human brain works. Problem number 2, we do not have a general theory of intelligence. Right? So what would mean a general theory of intelligence? Like, we have a general theory of information. Right? Here's one of the graphs that describes a general theory of information, where we describe a communication channel with source, transmitter, receiver, noise. We have math we add to it. We have this type of diagrams where we can calculate the entropy of a communication channel. Once we have developed this theory for communication, it was very easy to build communication channels. It was very easy to build communication devices. We had a theory that guided us so that we could, for example, calculate how much channel capacity we need. We could calculate some even better things. We could optimize the codes in the communication such that they are most reliable, such that they transfer the largest amount of information. We have nothing like this for intelligence. We are tapping, we are trying, we're using intuition. Today, an engineer who's devising a new AI solution is using mostly intuition, some sort of observing their own mind, and then looking like, how would I solve this problem, and then trying to come up with something. There's no fundamental theory. If we had a fundamental theory, things would be much, much easier. Then, problem number 3. We have a scaling problem. So all the AI that we have built so far, and we have built quite some impressive things, that's true. Like, we have really some awesome things. But all of these awesome things have one fundamental problem, and this is a scaling problem. They do not scale well in terms of intelligence. It means that if you have a certain type of solution and you want to improve its intelligence, the question is then how many resources you need to add in order to improve intelligence. And this does not scale well. To improve the intelligence a little bit, you have to add a lot of resources, way too many resources. It doesn't scale really well. Like, compare this. You have chimpanzee brain, human brain. Chimpanzee brain is only about 1/4 of a human brain. So it means that biological intelligence has increased intelligence from chimpanzee to human, like from living on trees to creating the entire civilization, by increasing the size of the brain by the factor of 4. And this is really, really small. This is really good scaling. Compare this to this graph that I just developed for the purpose of this talk. I look, how much more resources people need to throw into deep learning models for the simple MNIST task. And you see that there is an exponential function. If you want to increase the quality of your performance, you have to increase exponentially. You have to add exponentially more resources to it. That's not good for reaching human level intelligence. Here is a similar graph of like the biggest models that have been built so far. Right? And you see that over time, and you'll see here different types of models that NVIDIA built, Microsoft, OpenAI, and so on. This is exploding exponentially, and the growth is incredibly fast. Most recently, we have this GPT-3, which is not on the graph. You have here on the graph GPT-2 right here in the middle. Right? So OpenAI had first GPT-2 last year. This year, they came up with GPT-3, which is now 20 times bigger than the GPT-2. Right? So remember, we had 4 times bigger brain to move from apes to human. Now we have here 20 times bigger brain. We're not even close to ape intelligence, right? Or maybe that's arguable because of the function of GPT. It does language processing. So I'll take this back. But the speed of growth is of the resources needed for increased intelligence is not good. So that's generally what we see. Intelligence growing, resources required explodes. Now, consider mouse. Human brain is about 1,000 times bigger than mouse brain. I think that GPT increased in less than a year in a factor of 20. Right? So if you do 2 such steps, you have a factor of 400, 20 multiplied by 20. So, and that's less than 2 years. So the jump from mouse brain to human brain, the same amount of resources that GPT requires in its growing steps, if the next step will be the same size as the previous steps, is basically a period of 2 years. That's how much more resources GPT requires in a period of 2 years. Is the same amount of difference between the mouse brain and the human brain. So you see how much biological brain scales well in intelligence than our technology today. Problem number 4. With everything that we build today, and that is granted intelligent systems, we still keep tricking ourselves. Because whatever we build, we also project our intuition onto this intelligent system. And we tend to perceive them more intelligent, more human-like than they really are. And the basic illustration, to make this point, like look at this toy. Like, what is that toy? That's just a rug, a piece of material put on a hand. And it's good enough for us to inspire us to see an animal there, to give it a personality, to interact with it, to be all excited about it. Kids love it, of course. We humans also love things like this, cartoons, where you have basically something drawn on a piece of paper, and we start, adding to this, projecting intelligence into it. Right? Very easily. And that's what we do with robots as well, and with AI as well. Whatever AI does, we project more onto it. And one trick of doing this projection thing is just to add a little bit of emotional expression. So the talk just before me mentioned this same robot. I've seen it in the talk, and now here it is again, Sophia. Now, Sophia has some motors on her rubber face to make emotional expressions like disgust or happiness or things like that. Sometimes surprise is just to express surprise is just enough to raise your eyebrows a little bit. Oh, I am surprised. Then you raise the eyebrows. Now, this eyebrow raising, when we humans perceive it, we get tricked with it and we start feeling, God, it's like a real robot. It feels like a real robot. Like real intelligent machine. It has to be a real intelligent machine. No, it's not. It's actually not. It's just a trick that we play on ourselves. And we have to be careful not to fall for these tricks because we pay this price later, right? Problem number 5 is that there's a fundamental difference between how minds work, our minds, and how brain works. And this fundamental difference is really hurting us because all we can see is how minds work. We just reflect to our own minds. And we think like, oh, how do I solve this problem? Well, that's somehow how I have to make the machine solve the problem. We don't know how the brain do these things in the background, right? To understand this difference, like consider a question how smartphones work. So you could have a grandma principles, someone who doesn't understand the technology, doesn't understand the electronics behind it. So one explanation from a grandma would be something like, you swipe things with fingers, tap on recipes, and then you see recipes. Tap on the name of my granddaughter, and then the phone calls my granddaughter. That's how the phone works. This is the level at which we understand how our minds work. We just observe them. But then, of course, there is a technological level behind that engineers of phones understand. It's like ones and zeros and CPU and RAM and GPU and buses and all kinds of technological stuff in detail that engineer needs to build a phone for the grandmother. We don't have these details for the brain. For the minds, we have only the thinking part, and we are thinking about our own thinking. Even the math is, many people believe, including myself, the math is just expression, symbolic expression of the process of our thinking. We think, we count, then we come up with numbers, we write them down. Then we sum up, then we write down the process we summed up. We come and so on and so on, and through this process we come up with various mathematical equations and principles and so on. But it's all about our mind. It's all describing the processes of how our mind works. We have no access to the actual machine in the background. Now, these problems were easy to explain. Now, here's one harder one to explain, but it's very important, very, very important problem in machine learning. It's called the no free lunch theorem. And to illustrate this one, consider the following. You want to do a safari trip with this truck. It's a bit old truck, so it could break, and you're going way far out of civilization. So you want to bring tools with you to fix the truck if something breaks. Now imagine someone asks you the following question. Which one of the following should I bring with me on safari? Right? You have a choice to bring only one. Which one? Well, it's really hard to choose, because if you choose one of these wrenches, it will fit just for one type of screws, and all the other screws you cannot deal with. What in fact you need is a full box of tools. That's what you need. And that's some sort of a no free lunch in tool design for safari trip, right? If there's no single one you could pick, you have to have all of them. Well, similarly to that, there is a theorem in machine learning that exists, and it's called no free lunch in machine learning. And this theorem tells exactly the same thing. If you have one machine learning tool, pick any on this list, it will be good for certain types of problems, and it will necessarily be bad for different types of problems. And that's exactly the reason why we have so many different tools. We don't have one. We'll never have one. It will never exist. That's what the theorem tells us. Right? That's why we have linear regression and bias and decision trees. And within deep learning, we have different types of solution, convolution, autoencoder, and so on and so on. Right? And they're all good for certain types of problems, and they are really bad, they really suck for other types of problems. And that's why a data scientist and machine learning engineer has to have this entire bag of tools and work with them. Right? And that's a problem if you want to build. That's a very strong problem if you want to build something as smart as human. You have to figure out how did the human brain solve this problem. The human brain must be having exactly the same problem. It's suffering from a no free lunch. Right? Now, to understand that, let's look one type of a vicious cycle that machine learning engineers, creators of machine learning solutions, are fighting with every time, all the time, including those who try to solve how the brain works, including the brain itself. The human brain itself has to fight this following vicious cycle. Now, let's see this. So we had this machine learning metaphor, no free lunch metaphor with different sizes of ranches, right? Now, different sizes of ranches correspond here to models that have different architectures, or in statistics we call them different assumptions. It's the same problem, right? Now, somebody could come and say, hey, I have an idea. I'll come up with a general tool like this one. Aha, look at that one. So I will create a machine learning algorithm like a wrench that can be adjusted and can do things, that can do all kinds of different screws, right? A tool that can do all kind of different screws. Then, I could have also a machine learning algorithm that can do all kinds of different problems. So, for example, one could say that deep learning is something like this French wrench, or reinforcement learning is also a very general tool. So I have general tool, one for all tasks. And then we come to the problem of general intelligence. So look, if I can have a general tool, then I can have a general intelligence. The brain is general intelligence, and so on. We hear lots of such arguments, but I will explain you right now that this same argument falls for the no free lunch theorem, and there's always the same problem. And the problem is the following. If you have this French wrench that can be adjusted, would you bring it with yourself to the safari, and would you be satisfied and happy with that? Of course not, because you pay a price. If you have such a tool, yes, sure, you can use it for screws of different sizes, but still you have some type of limitations, and those limitations are that you cannot put it in a small space. Now, if your screw is somewhere in the engine, hidden behind some hose, you cannot approach there with such a big tool. You still need a small tool occasionally. And in machine learning, this is called the way this process is called inductive bias. And inductive bias is in machine learning is when you take a general approach and you help it out with some additional constraints such that it can learn better from data. Right? So basically, in machine learning, the problem is similar here. When you have a general tool, it pays a price by having either not being able to solve some problems, or requiring huge amounts of data, or requiring huge amounts of computation. There's always some price to pay. Right? Now, to understand inductive bias a little better and how it works, here's an example. Imagine we have a sine wave function that we want to detect and assess, right? But this sine wave function only produces these 3 data points. We have measured only these 3 data points. Can we detect it with machine learning? Can we say what is the phase of the sine wave behind and the amplitude? Well, it depends on which machine learning algorithm you use. If you use deep learning, some general stuff, you cannot. No way you could do that. But if you use very specialized models, one that has already in its equation sine function, then yes, then you can fit a sine function, and you can quite reliably estimate the phase of this sine wave, and you can quite reliably estimate the amplitude of this sine wave. And that's inductive bias, putting a sinusoidal function in it and saying, basically, look, I already know this is going to be sine waves, so look for sine waves. You're helping it. But then you specialize your model, and you make this very specialized model for this particular specialized task, right? And you don't need this extra data points. You can actually predict them accurately. Right? Now, what is the vicious cycle? You started with a model that works only for a limited set of problems. And you have new problems. So what do? you provide some generality, and you say, okay, I'll just loosen things up, and I'll make the model able to do more general things, and that's a deep learning model, right? That's the reinforcement learning model. But then you have a problem that you don't have enough data, you don't have enough computational power. Then you start twisting it. Now, once we invented deep learning models, they were not working so good in all kind of problems. So what did we do? We started giving them limitations. We started giving them new architectures, giving them new inductive biases. We add specificities. And then they work only for a limited set of problems. We're back to where we were before. And you're constantly going to run. Whenever you develop AI, whenever you do machine learning, you will always run into this cycle. And there is no way out, period. If you hope there is a magic that you can break this cycle, then you're just dreaming. That's science fiction. This doesn't exist, right? You could either be very general or you can be extremely specific or somewhere in between, but you will always be somewhere on this scale. Now, back to our Safari, like we could go for this extreme and say, I could bring this machine with me to Safari. That way I have like really general tool to solve all the problems. If something breaks on my car, I'll build a new part. I have my machine. Of course, you pay a price for having to transport this machine, having to find electricity, and so on and so on. Right? In machine learning, we have something similar, something that's of that scale of magnitude craziness. You would never take this to Safari. And there's something that we call in machine learning genetic algorithms. So these algorithms are even more general than deep learning or reinforcement learning. They're just extremely more general. They work like our own genetic, like own evolution. So in principle, they could, just by running over and over again, discover intelligence of the level of human intelligence. But of course, the price to pay is computational power, memory power, time requirements that are just not approachable. You may need like billions of years of computations to calculate this. That's always the same threshold, right? So let's make some conclusions now. So this means that we humans are not generally intelligent. There's nothing could be general intelligence. There's no general intelligence. Right? There are machines that are either more specific to some problems. There are machines that are more general, but then they pay price for this, so they're not really effective. So basically, general intelligence in a sense of, like, I will build a machine that will be always learn quickly for all the variety of different problems, and cheaply, and with small amounts of data. This cannot possibly exist. In other words, there is no free lunch in machine learning. In other words, it means that if this guy that you met in a park and who is so smart and says like he is smarter, it must be so that he doesn't know stuff that we humans do. His brain may have developed differently. His problems that he was working, evolution of his species and his own life were different than what we did. So he knows different stuff. Right? He may be smarter, but he knows different stuff. So if it ever happens to you to meet in a park an alien, and if it ever happens to you that an alien starts telling you, bragging about, my spaceship can go 99% of the light speed, blah, 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 and look at your car, how slow it is, and so on. Just tell him this. Sure, but can you do spaghetti? And I'm sure he will feel really small and envy of being stupid here, because he will not have no clue how to do that. Okay, so now, of course, the question comes, how are we then going to make intelligent machines? Right? If this is all the problem, so how are we going to solve this problem to make machines intelligent in the way human minds are, or human brains are? And I did not intend today to talk about it to much extent. There's a few talks that you can see elsewhere. If you Google my name on YouTube, you will find some interesting talks. I will just mention a little bit in the direction in which in which this has to go. And that's that basically what we have to organize is we have to have machine learning algorithms that are specialized. There's no other way. They have to be specialized, but they're going to be organized in a very particular interactive setup that will make them highly adaptive for the types of problems we humans encounter in our lives. And we'll be able to learn this type of problems. We'll still stay limited, we'll still stay within the no free lunch theorem, but we'll just flexibly navigate our own human world. And this architecture you see here. So on top of this architecture, you can imagine on top of this architecture something like your traditional AI. The one, your deep learning network, traditional deep learning network, right? And it operates very quickly. Now, one step below this, you can imagine some other machine learning device that is not your ordinary deep learning network. And this one is interacting with the world as well, but it's interacting in the world such that it first changes the deep learning network and then lets the deep learning network do its own job, and then it looks what has happened, and that's how it gets feedback. And then we don't stop there. We make another one that does the same trick and another one that does the same trick. And this architecture has a power to generate intelligent behavior quickly, efficiently, within the framework of human capabilities, provided one condition. And one condition is that at the very bottom, the last one of these boxes, has the intelligence level, has the capability level that corresponds, it's pretty much the same thing as what our genome does once we get born or conceived by parents. Right? And only if we get this architecture going, we can make machines human-like intelligent, like what you see here on the left line. And I will not talk more about it. I will finish now with the talk. I'll just mention that I'm right now writing a book called Next Generation AI, where I will describe in details how this has to be built. Not in technical details, more in conceptual details, how it has to be built. And please be tuned and patient until the book is out. So, and with that, thank you very much.
Thanks a lot, Danko, for joining in. Thank you for your amazing presentation and the thoughts that you gave to the audience. So, if you allow, we have few questions, very interesting questions from the audience, which I can just take it for you, and then you can answer those questions quickly.
Absolutely.
Great. So we have one question from Prabhat. So he's asking whether AI will actually help poor people, because what he thinks is, AI is something that will take up a lot of jobs. So what are your views on it?
Well, I mean, we have seen in the past machines taking over jobs from humans. Right? And in what happened every time, people were scared, people were afraid. But what happened over time is that at the end, the society as a whole advanced to the next level. Like the society got a higher quality of life. People had to change their jobs. People, somebody who was doing a certain type of job had to change and come up with a new job. So it always improved. It never went back in a sense that somebody came up with a machine and then suddenly masses of people were unemployed forever. It actually always created new jobs. And what's even more important, it created more interesting jobs, more fun jobs, less sweaty jobs, less difficult jobs, right? Because that's what machines tend to do. They tend to do the stupid stuff first, right? So it's like in the next, I don't know, several decades, we can think of, people will probably have to deal with this AI quite a bit. AI will need to have bosses, like people to guide them what to do. And so basically everybody will be a boss, or every human will be a boss, right? Like we are today boss of the machines, like my computer or my iron, my TV. people will be bosses of some robots or whatever. So it will be, they will have easier work to do, more thinking, decision level, less nitty gritty details. So I see very positive. I'm very, very optimistic about that, about the quality of life that it will bring.
Great. Thanks for answering that question, and I totally agree with your thoughts. And thanks for bringing in a new perspective in the minds, wherein everyone can become their own boss, or everyone will own a particular thing like a robot or a machine and become their boss. The next question that we have is again an interesting question from Ajay. He says that do we, like, when we dream or when we think, do we think in images, or do we think in languages?
Well, both. I mean, mostly what's happening is neither or. Like, most of our thinking is sort of unconscious, which means it doesn't reach any level where we can reflect on it and look what had happened. Right? So we think somehow neurons in the brain are negotiating something, and then this result of negotiation could be an image, but also could be a sentence. Depends on the person, depends on the situation. Very often it's both, in a sense that your mind creates an image, but in the same time creates a sentence that describes that image in a way. So but it could be just one, could be just the other, right? And it could be, in some situations, it could be neither. It could just go, the result of thinking could just go out as an output to your hands, to your movements, behavior, without actually consciously reflecting on what has just happened. And sometimes, when you're driving a car and you are having a conversation, and but this conversation may be images and language, working on that, while at the same time you're making decisions about the car, lane position, acceleration, taking over, changing lanes, and so on. None of it has to do with any images or any language. It's just happening in the background. You cannot reflect that.
Great. So the next question comes is like a yes or no question, kind of. So GAN or GPT, which is more powerful?
Yes. No, just kidding. I don't know, how do you define power, right? If you define the power intelligence as amount of resources, then GPT is probably most powerful. But I wouldn't agree with this argument necessarily. If you look at the flexibility that something gives you, I was now talking a lot about flexibility, and GAN gives you quite a bit of flexibility on various things that you can create with it. So in that sense, GAN may be more powerful, right? So we don't, as I mentioned, we don't have a theory of intelligence where we can accurately quantify which one is more intelligent. So I don't know, but I would be more on GAN, because when you take GAN, you also think of a learning process in behind. So you have to train your GAN and so on, and all this power together is much more powerful than a GPT already trained, and you have no access to making any changes to it anymore, which is the situation today. So
great, yeah.
GAN. I'm now definitely at GAN after thinking it through.
Great. Okay. So the next question is, it's since like we have most of the audience who are new into their technology, who are acting as freshers, who after a year, 2 or 3 would be out in the industry, helping corporates and helping organizations set up their technologies. So for these young audience, what do you suggest? Like, how do they start their journey on building an actual machine learning project, rather than apart from just learning the theories or the conceptual parts of it? How do they start their journey on building on projects?
Well, there's a quick way and there is a powerful way, and they're not the same in my experience. So correct. A quick way is to use examples, and then somebody tells you type this, download this, do this, and then very quickly you have your own thing running in your Jupyter notebook or whatever. And this may give you some satisfaction and power and feeling that you can accomplish things. And then there's the hard way, which will make you powerful. Take the theory and take just Python or just PyTorch and forget everything else and try to build out of equations your own code. And don't look anyone else. And spend 1 week building it. And remember that somebody had to do that. Somebody else had to do that in order for you to be able to download the tools. But if you go through this mental exercise and you spend a week, this will be, and you successfully finish it and you successfully create it, you will learn much more than through combination of theory and then downloading the result. You will actually have powers of building the actual machines out of concepts. And I have done that myself for the reason that I had no choice. When I was a young student many years ago, there were no tools. So I had to take C++ and equations and build my own deep learning networks, which were then called neural networks, from scratch. The learning algorithm, everything, like just for loops, right? You have for loops and then your basic numerics. And that's, it didn't work from the first try, but it works after trials. And I learned, that was the most powerful learning. Like what you learn that way, it's the most powerful. So do it, and then you will soon realize how much of a top expert you are. How quickly you will figure out later when something doesn't work in practice. You will be quicker than anyone else to realize, to figure out why it's not working and how to fix it and what needs to be done next.
Amazing. So we have many other questions, but we are very short in time. We have already had some technical glitches, and that has wasted some of our time. So what we'll do, Danko, is we'll email you some of the questions, and you can respond to some of them. We'll respond the same to the community members over the various groups of channels that we have, and maybe we can end up this session now because we are really short in time.
Yeah.
Thank you.
Okay.
Thanks a lot for joining in, and we really apologize for the inconvenience that has been caused. And we now think that the platform that we are using in currently should be much more stable.
Yeah. No problem. It was a pleasure being here. Don't worry about glitches. It happens. If you want to be at the edge of technology, you'll sometimes have trouble. That's life. That's life.
Thanks a lot, Dan. Thank you.
All right. Good. So you have a great conference.
Thank you.
Bye.
Thank you for being a part. Thank you. Bye. So to continue, guys, we have a very interesting workshop from the team Matic. So we have Ayush and Arjun from team Matic, who would be helping us understand how we can build scalable decentralized applications with Matic network. So we have Ayush and Arjun with us.
Hey guys, hi. I hope I'm visible. And Puneet, please let me know if you can hear me fine and if the audio
Yes,
is correct.
Arjun, you're totally
Yeah.
clear and I can hear you well. Hi,
All right,
Ayush.
perfect.
Ayush, you're on mute.
Hey, hi, Puneet. How are you doing?
We are doing good. Thanks, Arjun and Ayush, for joining in. So we are live. We have people joining in, and they are enjoying the particular sessions or series of sessions that we are having for the day. So without wasting much of a time, we would request you to get started, and the stage is yours. You can share your presentation by sharing the screen on the tab or on the button, and that's it.
Sure thing. So thanks so much, Puneet, for that, and we'll just dive right into it and get started. So again, once again, thanks so much to Zubi for setting this up and having this talk. And I was just listening to the talk prior to this one by Danko on artificial intelligence. Super interesting stuff. And we also towards the end just talked about the bleeding edge of technology. So we're going to talk a little bit about that today. So let me just share my screen. So again, so welcome to our presentation. So again, just to give you a quick intro about ourselves. So I'm Arjun, and I'm from I'm a part of Matic Network, and here at Matic Network, we built we work on blockchain technology. Along with me, I have Ayush. So Ayush is our solutions manager who's worked on many different types of blockchain solutions, who helps us actively develop our own technology. I lead some of the growth initiatives at Matic. And welcome to our presentation. So it's about building scalability apps with the Matic network, and how our technology is is sort of, or rather assisting or helping the blockchain ecosystem develop highly scalable apps with great user experience. So just to go right into it, so I'm going to assume that some of you, or maybe most of you, have heard a little bit about blockchain technology, and particularly Ethereum as one of the blockchains. But in case you haven't, so I'm just going to take maybe a couple of minutes to explain to you. And there's a really, while blockchain technology can sometimes be pretty complex, but there's a rather easy way to visualize it, right? So all of you know about the internet, right? Which is how we're connected and we're having this conference. But what the internet essentially does is acts as a networking layer. Right. So because we have the internet, and because all the computers around the world are networked thanks to the internet, we can sort of exchange information with each other. Right. So what blockchain does is that blockchain extends that. So if you imagine internet as a layer, a blockchain operates on top of the internet as another layer. And what blockchain does is it sort of builds a transaction layer on top of the network. So while the network allows you to communicate and sort of send information, it doesn't really allow you to do much more apart from that. What blockchain does is it allows you to do transactions on and sort of is like the transaction layer on top of the networking layer of internet. And the moment you visualize this, like okay, the internet is here, which connects everybody, and blockchain, which allows you to have transactions on top of the internet, and then you begin to understand, sort of visualize what it might look like, and what the problems associated with blockchain, with implementing blockchain technology might be, and what are the different problems it solves. So, and everything now makes sense if you start working backwards. So, okay, so if you want to do transactions with people across the internet, then of course you need a way to track those transactions. So you need a ledger, right, or some sort of a blockchain database. At the same time, if you are doing transactions, and you are storing those transactions in some sort of blockchain database or some sort of memory, then clearly you need some sort of computational power, right, which this blockchain network has to provide, so as to be able to track all those different transactions. So just working backwards from this simple premise of blockchain technology as a layer on top of the internet, and just working backwards and thinking through all the different problems you might have to solve to build a transaction layer on top of the internet, all of the other concepts related to blockchain will start to make sense. So, for example, you should have a distributed ledger, right? You need to have a ledger which cannot be hacked or cannot be changed. So, clearly, you need to use a system of cryptographic proofs to do that. You need asymmetric encryption, like, for example, public keys, private keys. And then when you read about the different literature about this, a lot of things will begin to make sense. Why mining is important, because it's a decentralized database, right? Nobody owns it. So clearly somebody has to maintain that database. And if somebody's maintaining that database, then there has to be some incentive for that, right? And that's what essentially mining is. It's a way of maintaining the blockchain database. You add blocks, you get incentivized for that. And of course, I'd encourage you to read about it. But when you want to visualize it just as a layer on top of technology, or rather on top of the internet technology, right? So you have networking, which just allows you to exchange information, and you build some sort of computation on top of that, like blockchain, which is a transaction system. So of course, when and of course, the story of how these kind of transactions goes way back. You talk about Zcash and the early 2000s, and then of course the infamous Bitcoin white paper, right, which details this technology. So the most interesting thing, right, is that the fact that people can transact with each other and across the internet, across the expanse of space, across continents, they can do that in a trustless manner. So the cryptographic proofs and the way the technology is implemented allows you to sort of solve for the trust problem. So for example, if I'm transacting, let's say, with Puneet, on this meeting, now I don't know Puneet, I've never met him before, but I can still safely transact with him and transfer value and get transfer value back. Gives sort of gives you the power to do limitless things, with respect to this kind of technology. So while Bitcoin was, maybe sort of envisaged so as a value transfer system where you send someone money and you get money back, several people who were developing or thinking about blockchain technology understood that you can do a lot more with blockchain, and that's kind of where blockchains like Ethereum came. So Ethereum is possibly one of the most popular blockchains out there, and in many ways the builders, or rather the creators of Ethereum, imagined Ethereum blockchain as a platform. So they said that it's no longer just a simple transaction system which allows you to transfer value. It sort of allows you to do many different things. And then the moment you sort of create a platform out of this and sort of bridge the trust problem in between people, so lots of other different kinds of interesting applications are possible. So that's kind of a bit more about Ethereum. And again, of course, I encourage you to, if you let's say are a blockchain beginner, to encourage you to read about blockchain, to read about Ethereum, which is one of the blockchains amongst many. So of course, so all of this sounds great, right? Blockchain technology, great. Now you had, the internet, which could, not do computations. Now you can do transactions, you solve trust, great. And you've got a platform like Ethereum, so you can build applications on top of that. But the story as of blockchain, as it is with many technologies, is not without its own sort of hiccups, right? So when so I think a lot of people just like myself, we learned about blockchain during that 2016 2017 phase when things went crazy, right? So there were, if you were looking at number of transactions happening on blockchains, there was this 2017 period which I've labeled as crazy, which sort of gives you an idea of how suddenly the technology got shot into the spotlight. Everybody was developing on it, everybody was talking about it, everybody said it's the second coming of the internet, etc., all of that. And people are talking about all sorts of interesting applications, how this will solve governance, poverty tracking, everything. And then something very interesting happened, right? So there was this which we call sort of the CryptoKitty phenomena, which is that somebody, so there was a very interesting team of developers who developed this concept of crypto kitties, right? So these were blockchain sort of tradables, right? These were, well, kitties, which you could sort of grow and trade, very similar to Pokemon. And this application became ultra popular. People traded their crypto kitties for values of up to $10,000. And this single application got so big that it threatened to clog the entire Ethereum blockchain. And it was so strange, right? I mean, this technology is supposed to solve the world's problems, and a kitten cat game has brought this network down. What's going on? And that's when a lot of the, you could say, drawbacks, a lot of the, you could say, challenges with the implementation and sort of the building of blockchain technology became very clear and apparent, right? So, and what you realize that one of the biggest barriers to blockchain adoption, especially with layer one blockchains, so for example, Bitcoin, Ethereum, EOS, these are layer one blockchains, is that you have very, very slow transactions. So when you do transactions on blockchain, especially even on Ethereum, they were super slow. There's a fees associated with all the transactions you're doing. So like I said, decentralized computer, you're doing transactions, somebody has to pay for it. And that payment for transferring, for doing transactions kept going up and up and up as more and more people got onto the platform. And this sort of slow transaction confirmations, these high transaction fees, on this blockchain network essentially created, what created a poor user experience. And poor user experience is possibly the number one killer of any technology out there. So obviously this, prompted a rethink, right? And how do we take this concept of blockchain, not abandon it, but how do we extend it in such a way that we can solve for slow transactions and we can solve for high transaction fees, so that it again, so that we can scale it now towards maybe enterprise grade applications. So how do we do something like this? And this sort of in many ways is the story of Matic, right? So Matic's first offering essentially is a hybrid proof of stake plasma sidechain. There's a lot to take in there, but to take it step by step, essentially we are a layer two blockchain on top of a layer one blockchain. So remember that story of the internet and the blockchain on top of that? Well, we are another layer on top of that. Realizing that a layer one blockchain, which sits right on top of the internet, is always going to be in many ways slower, or is always in many ways going to have transaction fee or transaction committability problems. So clearly we need to create another layer which allows high scalability, high throughput, is secure, is decentralized, so has all the advantages of blockchain, but at the same time promises you the scalability, or or essentially rather the user experience which you're used to on all your Android apps. Like the same user experience that you have on centralized systems, you should have the same one on decentralized systems. Otherwise, you're not going to get adoption. And and that's essentially what Matic was. Matic is a Plasma sidechain, so it's a type of sidechain built on the Plasma concept, and at the same time, it's a proof of stake consensus mechanism. So actors within the Matic ecosystem pledge their stake, or rather stake their tokens, and that's kind of how they become validators, and that's how the network grows and becomes more secure and more decentralized. And what we were able to sort of solve. So when we implemented Matic and implemented the Plasma sidechain, we sort of were in one shot able to solve almost all of the problems which plagued this initial CryptoKitty phase, or rather the layer one blockchain, right? So we were able to go from maybe 100 or 1,000 transactions per second to about 7,000 transactions per second. We had so many more transactions happening on a sidechain. We had 2-second block time, so the amount of time it would require for you to commit a transaction and on sort of to be for it to be saved on the blockchain became 2 seconds. There's finality on the main chain. So since we sit on top of the Ethereum blockchain, all transactions, every, let's say, 10 minutes are sort of, there's a Merkle root of all the transactions created, and it's committed on the main chain. So whatever activities or whatever transactions are happening on the Matic sidechain are completely secure. And if you want to sort of if you want to move onto the blockchain, onto the Matic sidechain from Ethereum, let's say, or you want to move back, all of your assets, all of your tokens, etc., are secure, and you can withdraw them at any time. You can add them at any time. So this flexibility essentially sort of created a situation where now, where earlier maybe it was super difficult to deal with layer one blockchains, to sort of deal with the low transaction speeds, high fees, things like that. By solving those problems, essentially what you've done is you created a low entry barrier for developers, right? So developers looking to hop onto the blockchain sort of side of things for development now essentially can do that thanks to these scalability problems being solved. And essentially, all of these scalability problems, which was solved, essentially created a focus on user experience. So, but there was a time when all the developers were trying to just focus on these scalability issues. But because we've taken that away, now the focus is back on user experience, and which is super important if you want to look at the adoption of blockchain, because you have to provide a a user experience which is similar to what you might get on your Android applications or any other centralized system. And so this is what Matic offers. And because we solve these issues, of course, we are now one of the fastest growing DApp platforms. We are one of the de facto platforms for blockchain games. So gaming is an interesting, way of stress testing your system, just like how the easiest way of sort of stress testing your laptop is try to play some high performance game on it, so you'll understand how powerful it actually is. Similarly, gamings with a huge number of transactions, so games have a huge focus on customer experience. Without a bad customer experience, your game can never be successful. And that's one of the so that's something which the games always look for, which is a huge number of people coming onto a platform, doing a huge number of transactions with each other. How do you offer great customer experience? And we've been able to do that. So we sort of become the de facto platform for several of the most popular blockchain games. We've got an exponentially growing developer community. This is, we have got on Discord channels. We have over, 40,000 people on our Telegram groups. We're on Twitter, and of course, lots of very reputed and very well-known applications, well-known networks, etc., are now talking to us and trying to, sort of make use of Matic's ability to, sort of scale at super low cost. And of course, we're working towards building one of the largest communities worldwide of developers and blockchain enthusiasts. So this is so by solving some of these scalability problems, we're able to essentially bring focus back, or bring sort of the fun back into blockchain, where people could again start building apps which solve real problems. Now, this is just a quick sort of overview of some of the applications which are on Matic. We've got several more moving onto a platform on a daily basis. We keep tweeting about them, so do follow our Twitter channel. You'll get to learn a lot more about Matic and all the different applications which we're working on, and all the other different platforms are talking to us. And of course, just to put it in one slide, if you look at things like, when you look at metrics like throughput, for example, when you look at metrics like transaction costs, latencies, how do you offer tooling support this is kind of where Matic shines, because Matic is like I said, a layer 2 blockchain on top of Ethereum. So everything which works on Ethereum works on Matic. So all of your knowledge which you've acquired on Ethereum as a developer transfers to Matic. Like there is literally nothing extra you need to learn. But at the same time, you get the high throughput, you get the super low transaction fees, you get the super low latency. And this is what allows you to build applications which are going to be popular with the customer, right? Which are going to attract users. Because that is essentially the biggest problem which we've seen, which developers developing decentralized applications have to face. Building the application is just one part of the story. How do you get a large number of users um, to interact or on or sort of come onto your platform or your application? So how do you do that? And that's where you need to offer that superior customer experience. So that's what Matic has been able to offer through our technology. And to quickly move on, we're partnering with some of the largest developer pools, largest applications, largest protocols all across the blockchain ecosystem who are talking to us, and looking to take advantage of Matic's high performance platform. And of course, like I said, we keep tweeting about this, we keep putting news out about this. So if you follow our Twitter channel, you'll get to see all the different partnerships which we've been coming up with over the past couple of months. Of course, so like I said, now that you've solved scalability, and you brought the fun back into blockchain, and now developers can actually focus on building amazing apps. So the problem which we needed to solve as a platform was, how do we create a platform which not only do uh, the not only do the customers love, who are interacting with apps built on Matic, but a platform which even our developers love. And this is kind of where Matic's developer first thinking, that how do we make our platform, because we're at the end of the day a technology platform, how do we make it super easy and super scalable for developers to use? And this is kind of where I just wanted to quickly take you through the development overview. So no skills required, right? To port over from Matic to Ethereum, everything which works on Ethereum works on Matic. So all of your platforms are supported. If you already have a DApp, let's say, and you're on, let's say, the Ethereum mainnet or some other platform, it's super easy to port it back onto Matic. We have extensive developer documentation. You can transfer your assets, your tokens, all of that on Matic, and then drastically reduce your transaction fees for all of your um, customers using a different DApps. So we made the transition part super easy. Again, connecting to Matic is very easy. You just need to, it's just a simple change in your RPC call, and voila, you're connected to the Matic network. So by making sort of the development and making the porting of apps super easy, we've created sort of this situation where we have developers, our developer community is growing, and we have so many more developers reaching out to us, because everybody wants a platform which is easy to use, which is scalable, so that you can focus on the real problem, which is business logic and how do you solve real problems for the customer. So again, so I'm just gonna stop right here and pass the rest of the slideshow on to Ayush, who's gonna take you through the workshop. Yeah, man, if you have any questions, feel free to put them in the comments, and we'd love to address those towards the end of the presentation. So over to you, Ayush.
Ayush, before you start, can I just take a minute?
Sure, Puneet, please go ahead.
Thanks. Ayush, I think you're on mute. Anyways, guys, so this particular workshop comes with a certificate. So if you want a certificate for attending this workshop and gaining knowledge through it, so just note down the points, whatever you learn in this particular workshop. And after the end of the conference, that is after the end of the third day of conference, which is on 22nd, you'll be getting a list of instructions on how you can take a particular assessment, and how after that particular assessment, you will get a certificate. The best part is the certificate that you will get is a certificate that is being issued on blockchain, so you can keep that with you, until you live. So just stay tuned and don't just attend this workshop, listen this workshop, take knowledge from this workshop, note points down, and take the assessment after the end of third day. Thank you.
Thanks, Puneet. Over to you, Ayush.
Yeah, yeah. So that was a great workshop, and whatever I think Arjun you've covered helps me to basically take it from here. So let me start sharing my screen. So I believe most of you would be really excited to understand and get started with the development aspect. So I've been coming from a developer background myself, and for me, it was pretty challenging to understand on the day one, how do I go about dApp development, and that was back in 2017, 2017ish, and I couldn't really figure out what to do and how to get onboarded, and that's where from there have been a lot of iterations that we did. I learned like from here and there, and that's what we have tried to curate a dApp development for you guys, and this would allow you to get started with dApp development. So without further ado, let me get started with very fundamentals on why would you really want to start with blockchain. So before you build on a blockchain, the essential question to ask yourself is, why do you really want to build on blockchain? What is there even a need, and why do we really want to move and make a transition from Web 2.0, that is the central server and client and server interaction, to Web 3.0, that is the decentralized interaction that we will be talking about. So also, like one really need to be aware of the developer tooling, because there is some set of interfaces and IDs that are required, which we will cover through this workshop, and that would allow you to get started with blockchain applications. So coming to the first question that we were having, is blockchain the right infrastructure? You would need to understand there are several questions that you would want to ask yourself first. So is the system defining digital relationships? So let's say we are trying to build and connect different entities together. That's when I think the blockchain use case comes pretty handy. Should data be dynamic and auditable? Should the data and interactions be managed by a central authority? Is community building a big aspect of your product? So like there are several when you build a dApp, there are other aspects of the dApp. You would really want to build around a community so that people are really aware of it, and that's where also Matic comes in play to basically publicize and publish the dApp that you will be building. So that's a community aspect that we will be covering at the end. Is transparency and compliance a key tenet of your product? So blockchain, as you might be aware of, is clearly when there is good amount of transparency and compliance that we're looking forward to. That's when the potential of blockchain and the dApps come in play. Does your application require global financial transactions? A pretty good use case of blockchain again. Does your application require interactions between multiple conflict of interest third party? So with this point highlights, and as you might be clearly seeing some examples where supply chain is coming in place, right? So there are different entities, and from one source to the destination, there are different middlemen and various other parties coming in play. And that's when all of them are interacting with one single dApp, there is one source of truth that they are interacting with. So there is not like different databases where the parties or the customers or the vendors or the users who are interacting are having different databases. All of them are in one single blockchain, and that's when the dApps or the blockchain infrastructure comes pretty handy. Now, switching from Web 2.0 to Web 3.0 is not simply just in terms of development. We got to understand few things which are very fundamental to Web 3 development as of now. The memory is limited. So every transaction, every write operation that you do on blockchain, it's the memory for that is pretty limited. So you want to understand what's the use case. That is it textual? Is it heavy? Are we talking about meta transactions, or are we talking about like heavy data transactions that we would want to? So in terms of memory, there is very limited memory that is required and that we support. In terms of like blockchain infrastructure altogether, then the computational capacity is also limited. So if you understand what is happening at the crux of it, is there are different nodes, and all of them are in a distributed and decentralized manner operating and trying to execute the same thing. So if you do try to make a note of it, like the nodes are having that capacity to compute what operation you are trying to do, but at the same time there are other nodes as well which are trying to do the same thing. So that's where the computational capacity gets limited. Then reading data is free. So whatever you are trying to access from the blockchain and trying to retrieve it, that's free. But every every time you try to write something and there is change of state operation on blockchain, that's when a cost gets incurred. Even though now that has come a far like way what it was or what it used to be now, but yes, there's definitely a cost associated to a transaction. Now, how is Matic helping out? There are two platforms or two bridges that we support. One is primarily focusing on the security, and that's the plasma contracts. The other that's there is proof of stake, which allows the speed and primarily focuses on the speed aspect. There are dev tooling as well, like how I was trying to mention. When a user does a transaction or is trying to operate with the dApp, the user does not really have to bear the fee or needs to really understand why do I need to pay for something. And that's when meta transactions come in pretty handy. The dApp development or the dApp developer has to make sure that meta transactions are integrated. So at the crux of it, the dApp itself is responsible for the payment of the write operation. But yes, that write operation or whenever the user is interacting with the dApp, there is a cost that gets incurred. But on Matic, that's pretty less. So that's where we are in a pretty good state as well. Now coming to dev tooling again, how I was mentioning that we have different tools altogether for blockchain infrastructure that we need to understand. And all of these tools are pretty common for the de facto of blockchain, which you might have heard in 2017, that's Ethereum. But so like Truffle, Ganache, Remix ID, which we would be going through as well. These are all the dev tooling that is required to build a blockchain app. Now, wallet integrations, it's pretty important to understand that you are interacting with the dApp with the help of a wallet. And that's where the Web 3.0 interaction is enabled by the wallet that you're seeing on the screen. So Fortmatic, Fortis, MetaMask, Taurus are some of the pretty highly used wallets, and all of them are integrated with Matic as of today. Then there are oracles. So in blockchain, like the smart contracts are just sitting on nodes, not aware of what is the outside world trying to say. So that's when oracles are required. So think of it like as some API, like how we make use of the APIs, and we would want to get some third-party information from other sources. That's what oracles try to do, and there are like different oracles that Matic has integrated with. That is Chainlink, Bandchain, Razor, and Provable. So all of these basically cover the price aspect. Let's say if we want to get a value where we want to understand what is the price of BTC today at this particular moment, that's where we make a call to the outside world, because smart contracts are nothing but essentially a piece of code written and running on those nodes, and those nodes are sitting across in a decentralized manner. Other than that, we do have decentralized storage, Moibit, we have BlockVigil and Anchor. And so we have a pretty intuitive documentation which would help you support and build the dApp as well. But I have already come with an dApp which would help you allow to get a good understanding. And so I am very fond of traveling, and what I could come up with something which would relate, which you guys could relate to as well. Something like Airbnb, but in a decentralized manner. So what we are going to work on and we are going to learn today is dApp, which is a decentralized Airbnb. And without further ado, I believe Puneet might have shared the link with you guys, and you are having, yeah, so I'm assuming you have the link. Is there any question as of now you would want to ask before we get started to the development aspect and look into the dApp development? Puneet, I'm assuming you have shared the link with each, right?
Yes, I did.
Great,
Yes,
great,
it's on the comment section, guys. So you can just take the link from the comment section, and you can download the file.
great. So, okay, even for those people who have not been able to download or in some way are not able to follow, I would try to make it as comprehensive as possible so that you guys are able to follow and then deploy your own smart contract and essentially make your dApp as well. So coming back to how we were talking about the smart contracts, right? So what you're seeing in front of your screen is a remix ID. So if you go to remix.ethereum.org, that's where you would be able to deploy your contract. So I have already a contract which is available and it's in the code as well. So if you are following, you would be able to find the contract. Like I have the files open as well. This is how the folder structure would look like. If you unzip the file that I have shared, this is how it would look like for you. And if you go under mhm. So if you go under contracts, you would be able to see the Airbnb.sol, and that's what you can pick up from there, and you can deploy the same code which you can see in the contracts.sol, Airbnb.sol on the remix. So over here, I have already done that, and you would need to basically compile it and then make use of injected Web3 so that you are able to deploy it. And the link that you need to have as well, which I would be sharing in the chat section as well, is the Mumbai Matic network. And I'll just show you in your MetaMask, you would have to configure the RPC URL link. And the RPC URL link, I'll just put it across as well. Okay. Sorry, my internet is acting up a little.
Also, Ayush, would be great if you can just zoom in a bit on your code used in Remix or on your ID.
Oh, right. Okay, great. So I'll just share this link as well so that anyone who's following what we are trying to do will be able to have hold of it. Okay, now coming back to Remix. Okay, Puneet, I'll just thanks for this. How is it now? Is it now visible? Like
Yeah, it's a lot better.
great. So what you're seeing on the screen, guys, is a smart contract that's written for Airbnb, and what we'll just walk you through the contract as well. So what we're trying to do in the contract is there is one struct of property that we have created, which would have the name, description, is the property active, what's the pricing for a day, and the owner, whoever has created that property. And with this, we would have a boolean which would allow is if the property is booked for a particular day or not. For the sake of simplicity, what we have tried to do is for one particular day, let's say we are talking about Jan of 1st, we have considered it as a value of 0. So accordingly, from like Jan 2 would be 1, Jan 3 would be 2, and so on. So this bool would be having values till 365. Uh, so from 0 to 364 rather. So this is again, now we have a mapping which is for the property ID, and then we have a mapping which would allow us to get which of the property we are talking about. Then we have a booking struct which would allow the application to register that the booking has been made for which date, and this is the check-in date and this is the checkout date that we're talking about, and for which user. So if you understand, all of the constructs that are there in Solidity are a lot different than what we have in traditional languages. So some of the like not lot, but I would say like very pretty similar. And so if you see for a user, there is one address that is there, and which is not there in the traditional languages. But so for every wallet that a user has, it can be the construct for that is address, and rest all constructs, whatever you're seeing, the data types are string, bool, uint, which I'm sure you might be using in the traditional languages as well. So other than that, we have one event. Event allows you to basically read whenever there is a new property that's created. And then whenever there is a new booking, there's an event. So event is something which would trigger which would get triggered, and you can fetch it on the front end. So as we said, breeding is free, and every time there's a new property that gets registered, and every time there's a new booking that is there, the event gets called. Then we have a function which is having the logic for renting out. Like once you are trying to make a booking, that's what this is the function you will call. Then we have rent property. Um, then we have send funds. So if you understand these send funds, create booking, all of them are internal functions. So basically, they are getting used in some of the functions which are being called externally. And that's like one more function that I would want to point out to mark property as inactive. Yeah, so this basically covers the contract, and it's a pretty simple and basic contract for you to be able to play around with it, deploy it, and check it out yourself. And in a at a whole, I would be showing you the DApp, which you can see over here. So over here, what I've tried to do is basically run the DApp beforehand, and I'll be showing you the interaction as well as the files that we are interacting with. And as of now, what you're seeing is a Vue framework app and a Vue library app rather. And this is basically interacting with the contract. So let me just refresh my page again. Right. So if you are having the app yourself, when you run the application, which is what let's just try stopping this application and then running it, you would be able to rent your property. That is, you can create your own property here, make a booking. So all of them, all of the activities which you are seeing is live. And since we are all interacting with the same contract, we would be able to see your property as well over here if you're doing so. So I'll just stop this application and start so that you follow the same instructions. As of now, what I'm running, since this is the project, okay, I'll just zoom in a little here as well. Okay. Is it visible now?
A bit
Okay.
more zoom would be good.
A little more?
Yes.
Great, great. Okay, so once you have the file structure, what you can do is you can open it on any suitable ID of your own choice. I have chosen VS Code for today's session. And over here, once you are there in the terminal, you can just go to npm run dev, and that would be about it. Like once you do that, you can straight away run the project, and everything else, the node modules, everything is all pretty packed up in the zip file. So you don't have to really install the node modules and check your node version and everything. The only command that you need to run is npm run dev and let it do the job, and it would serve all the files, do what is required, bundle them up together, and serve it on the client. Now we'll obviously be discussing on when each and every function is getting called, how are we interacting with the code. So as of now, what you would be having in front of your system is a setup like this, and this is where like the zip, when you unzip it, this is how the file structure would look like. We need to have the DApp UI open since we are interacting with the DApp, and the component section open, as well as layouts, pages, and plugins. That would be what we would be going through. So again, like now it is running, and it's getting served on port 3000, as you can see. So I have it already opened. Now what you're seeing is the DApp that we'll be interacting with. So you obviously would require to have MetaMask installed as well. In case you haven't, I would recommend you just install a Chrome plugin called MetaMask. What MetaMask is allowing you to do is interact with the blockchain world. So understand it as a portal that which allows you to interact with the Web 3.0 system. And this is pretty much like for this use case or this scenario, we would definitely need to have MetaMask. And on that, you would have to go to the custom RPC URL. I have already made Matic Mumbai here, but you would have to choose custom RPC and then choose again put in the RPC URL, right? That's already created for me. So once you save it, you would be on the same chain which you are seeing on the screen, right? So there are different networks already, but what we are making use of for this particular demo is Matic Mumbai for now. Okay, now coming to the main point, that this is where we are interacting with the dApp, and let's start with renting your own property. So, okay, let me put, okay, my Bengaluru house is currently not coming in use. Let me put it on Airbnb. Okay, uh, available for stay for about a month. Now, price, as of now, for the sake of simplicity, if you do understand, this is ethers we are talking about. And over here, we are talking about Matic. On Ethereum chain, when you interact with the contract, you are making use of the gas fee in terms of Ether, and that's the price value that you put in on Ether. And in a similar analogy, we have something corresponding that is on our chain, we make use of Matic token. So one Matic token is basically having the value of 10 raised to power 18. So if you basically understand, I do not want to put one. That would mean one entire Matic token. And for now, for the sake of simplicity, let me just keep it as 0.001. So what I'm trying to do here is, if you have a look again at my MetaMask, as of now, what I have is, again, okay, just a second. I'll configure the network again so that we are out of confusion. So essentially, what I'm trying to do is switching the currency so that you're not able you get what we are trying to do. As of now, what I have is 0.9 Matic, and that is when I would be renting my property and I would be trying to book it. So I do not want to surpass the value 1. And so I'll again. Uh, 31st December. Okay, now again, I'll be putting up the price, which is going to be in terms of Matic. And as of now, I will put 0.001. Now, when I do submit, there would be a MetaMask pop-up, and this is where I'm writing to the blockchain. So I'm interacting with the blockchain now, and I'm changing the state of the contract. Now, for that, you have to incur a gas fee. That is how the contract is written today. And once we confirm, the transaction gets processed, and we'll just get a confirmation that our property gets listed. So property is posted successfully. You can see it happened pretty quickly. Now, again, I'll just refresh the page. And here we have another property created, and that's a card that we have created. So now we'll just try to relate to what we did through the code that is written, so that it is better for you to play around and make any changes that you would want to do, right? So rent your property is what you're seeing. This gets covered under nav bar. But okay, let's just jump into what we have as a code structure, right? So if you see, there is one contract. We have Airbnb, then we have migrations as well. That is, if you are making use of Truffle. As of now, we made use of Remix for the deployment. So this contract did not really come in play today. So dApp UI, that is the UI that we are seeing on the screen. For dApp DUI, then there is Nux folder that is getting created. This is because we, of course, served the files which you are seeing on the client side, the assets which are required, the components. Now, this is where the 4 components that you can see: the cards, the pop-up, and the navbar, and the property form, right? So the card that you are seeing is this card we're talking about. The details module that is getting popped up every time we are doing this. This is the details pop-up. The nav bar, this is the nav bar we are talking about, which is having rent your property, and and the property form again. So if you let's just change the nav bar a little. We can have, let's just do this and see the changes. And okay, I am serving dot next folder. I'll have to like, okay. So we can do this. We'll have to stop the server. We have to serve the files again, and then those files or the changes would be getting reflected. So as of now, I'll just skip that. And yeah. So okay, card details module, navbar, property form. This allows you to basically, these are the small components that are getting used. And then we have the default layout, and then the main page which is getting served, that is the index.view. Over here is where you are seeing like the Letcon workshop and the cards getting rendered. So all of them, like the card and all the components that we are required, you will be able to find it here, right? And then there is plugins. What do we mean by plugins? So as of now, if you understand how we are able to interact with the contract, right? Like what we saw over here, there was one contract which we deployed. Now, how do we make or how do we interact with the contract is we require the ABI file for this contract, right? So if you go here in, we are checking out Remix right now, and you have like a small button which allows you to copy the ABI. So what this does is allows you to get the API so that you can interact with the contract, and the API as well as the contract address is what is required for you to basically interact with any contract on a particular chain. So this is where again, like I copied that, when I paste it again, it's the same thing we are talking about. And right, so this is the JSON file, and it's in a JSON structure. Then a utils file is where, like how Arjun had shown in the slide as well. So how you interact with the Matic chain today is just a simple piece of code which allows you to basically get started with Matic chain today. And this is where it's the RPC URL, which is for you guys to try it out, and it's available public. And this is the contract address for Airbnb. So if you deploy your own instance, you would have your own contract. And as of now, if you see, this is the contract address that I'm pointing to. That's 372, and this is where, like whatever you are seeing, this is the contract. We can interact with on Remix as well, but that's when we have tried to glue the front end with the back end. And this is the contract which you are interacting with over here. So if you create any of, let's say, whatever property or whatever you, let's say we check out what was created on value 1, this will show you all the values which we just created, because it's starting from 0th index, and that's where the My Bangalore house and all the stuff which we created are visible. So this is the contract instance which we are interacting. Coming back again, wallet connect, we do not read in this demo, and the config file. Yeah, so that's pretty much about the files that you would be needing info on. Feel free to try it out, play around, and check it out yourself. And is there anything you would want to ask me? You can put it under the comment section. I would definitely want to help you guys out. These are some of the dependencies which are already pre-installed. So node modules are already installed for you guys. So over here, the node modules are there. Generally, there's a version issue sometime or the other if you're not on the same node version. And that's where it was pre-installed in the zip file as well. And again, like in case you have any queries, or in case there is anything that's stopping you to play around with the app, feel free to let me know. Other than that, some helpful link which would be required for you as well would be the Matic Explorer. So, okay, let me open the Mumbai Explorer Matic network. So over here, what you're seeing is the number of transactions, or like it's the complete dashboard, which allows you to have the view of every transaction that whichever, or when you are interacting with the contracts, the transactions are visible on this Explorer. So as of now, when I did a transaction, let me just check out. There is a way where I just did a contract interaction, and that is visible under the activity through this account. So let me just check this out. And when I do this, I get the same link open. And when I'm doing this, it gives you some meta information about the transaction that we did. Uh, yeah, and as of now, for this card, what we created is it was about booking. It was putting our property out there. I would want to show you guys even the booking that we can do. So we put in a price for 0.001, right? Let's just try out and let's just book. I think I'm kind of available the next weekend. So let me just book my house for next weekend. Try it out myself, right? So what I'm trying to do is I am seeing the same card, the details, and I'm trying to book the same property, right? So one thing that is going to come handy for you to understand over here is what do we mean by scalable? So as of this point, if let's say there are multiple concurrent calls that are happening, right? How long will it take for any transaction to get confirmed is what we mean by scalability, right? So when Arjun mentioned that today we are able to process 7,000 transactions per second, what it means is if at a different in different time zones at different places we are trying to interact with the same contract, in a matter of seconds there are 7,000 transactions that are getting confirmed, and that's what you would be able to check out yourself as well. So for an average block time is about 2 seconds. So in one block there are multiple thousands of transactions that are visible, and you can see the blocks getting generated. But coming back to the portal that we were seeing again, I am now trying to make a booking, and yeah. So again, now when I'm doing another transaction or when I'm trying to interact with the contract, the MetaMask gets popped up. And if you see what this MetaMask is also showing is 0.0001. That's the price for 1 day. And I've chosen the price. So let me just book the my house for 2 days. Let me show you that it's going to be obviously double. That's what MetaMask would show you as well. And then there's a gas fee associated to it. So the entire cost comes out to be 0.002123 Matic tokens, right? So I'll just confirm it. And when I'm as of now, the transaction has not been confirmed. So I just really quickly want to see what's getting displayed. So if you see, okay, now it has already been confirmed. But so this is like gives you an idea that, and again, if we go back, the property was booked successfully, right? So this transaction has been confirmed, and this is the transaction details that you're seeing with what we just did. That is the interaction. What we just did is visible here. So it's like raw input, and yeah, that is how it is today. Then there is nonce, block confirmation, transaction fee associated with the same transaction. And in a way, we were able to do a complete flow from renting out the property to booking a property and basically able to view it. So in that zip folder, if you check out, there is pretty interesting, like it's like the entire DApp is available for you to play around. It's your own imagination. You can build it further. You can put out CSS to it. You can put out images to it, right? So there is multiple things, as Puneet was mentioning. If it's part of your assessment, I would definitely suggest make this better, make it more like beautify it a little. And there are multiple things you can try it out, right? So let's say showing who has already been who has booked it on what date, right? So there are multiple contract logic that are already written. So if you go back and if you check out the contract, you will be able to see that once the property has been booked for a particular date, you cannot, like another user cannot like book for the same particular date. So that's where what, like if the property is booked for a particular day, you cannot really have it booked for another user. So all those logics have been written, but I would suggest do understand, try, like the code comment is there for you to understand, check it out yourself, change the logic, deploy it, and feel free to reach out over the Matic channel as well, or like on Twitter personally. right? So this is a pretty interesting concept since dApps are gonna be there for the next like 5 years or 10 years for sure, and till then, I think uh, yeah, like these tools and the scalable dApps are gonna come pretty handy. With that, I would want to hand over to Arjun back again so that he can prize you on the initiatives that we are taking so that there are more and more developers who are in that zone of learning can get onboarded and learn on building on Matic. So, Arjun,
Sure thing. Thanks, Ayush, for taking the workshop. And yeah, and again, I just want to also just say to the audience, apologies if it got a bit technical. But that being said, like how Ayush was saying, our developer documentation is very comprehensive. If you go through it, you'll get a clear understanding of many of these concepts. I do understand that many of you are complete beginners as well, which is why it would make sense to start with. Let me just quickly share my screen. Just give me a second. Great. So if I were to just go to the Matic website, and if you can just, if you want to go to the developer documentation, you can start with the sort of getting started guide, and it'll give you a very clear understanding of how you can go about doing it, all the different things you talked about. Like, for example, you talked about the Matic, the SDK, how the block explorer works. We have communities on Telegram, Dev Forum. So in case if you found some of these some of the topics a bit more technical, you'd like to learn more, there's a lot of documentation. I would encourage you to read the white paper as well to get a basic understanding. You can learn about blockchain basics. If you're already a developer, or if you want to learn about development, there's several links there as well. How validators work, how the integration partners are supposed to work. So I encourage you to go through this, and it'll give you, and if you go through this documentation, you'll begin to understand. And then if you take this knowledge and then sort of look at the application which I used to share, a lot of things which possibly didn't make sense initially would make sense. And the code is there for you, so you can go through it at your leisure. Analyze it and try and understand how transactions work, how you have to write the smart contract, and the business logic. So what parts of the application go onto the blockchain versus what stay outside of the blockchain on the front end side. So I encourage you to go through this. And of course, we're there on all of the Telegram channels, on Discord. So if you have any questions around how you're supposed to go about doing this, any specific technical queries, if you're building apps, we'd love to engage with you there and sort of answer any questions. So let me also move ahead and talk to you about some of the campaigns and what we've been doing for the developer community, right? So like I was saying, right? So whenever you want to get successful with a DApp or decentralized application, essentially there are two parts to the problem. So number one would be getting the technology right? So creating a fantastic app which gives you great user experience and testing it and doing all the things you would normally do as a software developer. But the second challenge, or the biggest challenge to solve, which makes or breaks a decentralized app or a DApp, is essentially getting lots and lots of users onto your platform. And this is kind of where this is kind of where Matic, as a platform, has put a lot of focus. We have dedicated teams to help you sort of get the word out, to help you with technical queries, to help you with how to market your app, things like that. We're also running several programs, so I want to talk to you about those as well. But we have several launch campaigns, giveaways, the several promotions we keep running. We connected to all the top blockchain influencers. We do regular community outreaches. So, for example, if you come onto our platform and develop a great app, we tweet about it. We'll sort of send out information on the Reddit groups, 4chan, all the different forums out there. Tweet about it. So this is kind of our way of helping DApp makers or people who are interested in making DApps, help them sort of be successful. Because if you are successful, then as a platform, we are successful. And that's kind of what our thought process is when it comes to doing all of these things. Of course, there's also grant support. So for many interesting or different ideas, and I'm going to talk a little more about grant support in the next slide, but we help with that. We also help with game testing. So blockchain games is a very popular medium for consumers to interact with the blockchain, sometimes for the first time. So of course we help with testing as well. Um, so of course, like I said, our mentality always is developer first. What we can do to help you succeed. But we have several programs running to help developers, right from people who may have developed comprehensive blockchain apps to people who are complete beginners. But of course, I want to talk about three main programs which we have going on right now. So we have a build and earn program. So the whole idea behind the build and earn program is to encourage developers to make interesting, decentralized applications, and essentially be able to sort of fund them in a way that they can, sort of cover their running costs and focus on the application versus having to, sort of solve for everything at once, which is consumers, funding, etc. So essentially, there's going to be a $50,000 pool, which is going to be distributed every month. This is supported by Gitcoin. So we're doing this along with Gitcoin, and there's going to be a community-led voting process. So all the apps which the community finds super interesting, they will vote on it, and those apps will get funding. So it's in your interest to go after interesting or relevant use cases. And again, of course, we will provide dedicated marketing support within the Matic community and beyond. So we're going to help you market your apps. We're going to help you with how to position them and any other help which you might require to be successful. So Build and Earn has been one of our most successful sort of incubators of sorts. We've had several, applications sent to us. So I would encourage you to just, and all of this is there on our website. So if you just type Build and Earn, if you just Google Build and Earn Matic, you'll get the link, and you can learn more about the program. Along with that, we also have the Matic Jedi. So this is sort of a virtual hackathon which is going on this month, and it's there till the 6th of September. So we have a range of bounty tracks, prizes equaling $3,000. So we want again developers to build interesting things on the Matic network. Again, you can Google this, read about it, and within the comments, I want to post some of these links so that you can get to know more about these programs. And what we've also done is come up with a decentralized finance program, what we call DeFi. So we want to support the new DeFi wave of so this wave of new DeFi applications, decentralized finance applications coming onto the blockchain. And to run successful decentralized finance applications, you need high scalability, you need low transaction fees, and this is kind of where Matic really shows its true strength. So we've actually put together $5 million, which will be pledged for developers looking to build innovative solutions in the decentralized finance space. And of course, we'll offer them all dedicated marketing support within the Matic community and beyond. And of course, we have like so many hackathons, bug bounties, smart contract bounties, where you can read, go through smart contracts, figure out if there are some errors and there are bounties related to that. And we keep doing all sorts of interesting giveaways. So keep following Matic, follow us on Twitter, where we post a lot of our announcements. Check out our website if you want to learn how to be a developer, right from blockchain basics to a final app, which Ayush demoed. And like I said, I understand that some of you may not have understood all the concepts or got all the applications right, which is perfectly fine. Just follow the documentation which is there on our website, and if you look at the code after that, you will get a very clear understanding of what's happening and how easy it is or intuitive it is to build decentralized applications compared to what some of you might think. So that's about. So this is kind of brings me to the end of our presentation. So I hope this was helpful. I hope we were able to give you a good flavor of what Matic is all about. And of course, if you have any questions, feel free to ask. You can ask us here. You can engage us on the developer forums as well. And what I'm going to do is definitely post some of these links which I talked about, like with respect to our Build and Earn program, with respect to our Jedi program, and please, I would love it if you participate, learn more about decentralized applications, and take part in sort of this blockchain movement. So yeah, so thank you for your time.
Great, thanks Arjun and Ayush for a powerful workshop and a session on what exactly Matic is and how these students who are beginners in their field, how they can go through the documentation, how the developers who are already building, how they can actually explore the various programs of Matic, wherein they support you to go into the market to fund your applications, to get a team for you, and a lot of many other activities. Great to see all of those, and thanks Matic and your team to support the developers out there. We have quick questions for you all. So the first question is from Imran. He asks, can we use Matic on game engines like CellerX or CocoaX?
So yeah,
So,
yeah. Please go ahead, Ayush.
So instead of using Matic on them, basically how it works is they come on to Matic. So whenever like we have like tons of games which are already on the Matic chain. So how it works out is like you use these game engines to create those graphics and the models, the 3D models that are generally created, and all of them are then linked onto Matic chain, and then basically the states are preserved on Matic. So yes, definitely you can project it and architect it in such a manner that these even Unity for that matter can be worked around with Matic as well.
Great. Thanks, Ayush. So the next question that comes. So we all have heard about particular concept called Merkle trees. We have heard that in terms of in the in the blockchain industry. So there's a
Mhm.
question by Raj. He asks how important are Merkle trees in blockchain, and I'm just adding to what he has asked. Where exactly are Merkle trees being used, and how is it important in terms of Bitcoin blockchain or Ethereum blockchain?
So definitely. So I think Merkle trees in many ways forms the backbone of how blockchains operate. So for example, so essentially what Merkle tree or a Merkle root allows you is to take a huge amount of information and essentially compress it into one string, right? And once you have that string, so how Merkle trees work in the blockchain space is that for every transaction which you do on the blockchain, there is a hash generated, right? And that's a unique alphanumeric key which is generated every time which is generated for every transaction or every, and it can be generated for every piece of data. And if there is any change in the data, the hash changes. And what Merkle tree allows us to do is to take, let's say, hundreds of transactions, calculate all of their hashes, and essentially compress that hash into one single hash, which is the Merkle root of the tree, right? And essentially, that Merkle root is what is committed onto the blockchain. So what this allows you to do is it allows you to take a huge amount of information, compress it into one alphanumeric key, and store that onto the blockchain. So if there is any change in any of the information for which you've calculated the root, then the root would change. So this way you can take so for example, if you have a million transactions, you don't have to check each and every transaction to check if it's valid. You can actually just take all of the hashes of those transactions, create a Merkle tree, calculate the Merkle root, and if anything changes in those millions of transactions, if anything changes, the Merkle root would change. So this kind of a concept of being able to prove whether a data point has changed or not is how Merkle root is applied within blockchains, and this sort of in many ways is very central to the concept of being able to check the validity of transactions or to be able to build blockchains where if you change anything, any sort of entry, the blockchain would reject that transaction. So I don't know if this was very intuitive, but it's a very specific technical question. So I hope I was able to answer it the right way.
Yeah, absolutely, Arjun. That really helps, and the way that you have presented it out, it's definitely helpful for beginners to understand on how exactly it works. If there's anything that gets added or changed, the entire Merkle root change, through which
Hmm.
you can get an idea with whether the same thing is valid or invalid, or whether it has been
Absolutely.
tampered or untampered. Right? So the
Yes.
next question that comes in is like we all know storing anything on blockchain is quite is quite on a hefty side or is quite not economical. So there's a
Okay.
question from Mayank who asks, what about large amount of data? How do we
Hmm.
store it? Like on distributed systems like or distributed databases like Cassandra?
Hmm.
How exactly things work on blockchain? How do we store like these high size files?
Sure. Ayush, you want to talk about how we've integrated IPFS with blockchain? Yeah.
Yes, yes. So, Preet, and so if I have to answer this, there are different decentralized storages out there who are trying to solve the same problem. So the decentralized storages are like blockchain for storage, right? So like the images that we see, the invoices that are created, and even anything which is like data heavy that gets stored on distributed storages like IPFS, which is a pretty common example that everyone is using nowadays. And there is a hash that gets generated for that particular document, which is stored on the contract. So that is what is getting stored on the contract, and that's where the blockchain is just having that single hash for that particular file. So what it turns out is the cost is again at the end comes out to be very minimal, and the storage that is used is decentralized storage, so the data is also protected. And anything, again, like how Arjun was mentioning, if there is any tamper of that data, if the video is edited or audio, image, whatever is the case, the hash again changes. So IPFS also works in a similar scenario, and that's where like Merkle roots have saved our lives, like made our lives a lot easier. Yeah.
No, definitely. And the best thing about IPFS is that whenever you store something on IPFS, it automatically generates a hash, right? So it's sort of in many ways seamlessly integrates with blockchain. And for the uninitiated, IPFS stands for Interplanetary File System, right? So it's designed for huge amounts of storage. Even I read it the first time, I was like, interplanetary, really? No, but it actually is designed for massive scalability. So if you have huge amounts of data, you can push that into IPFS, no questions asked. You generate the hashes, and just like how Ayush said, you take that hash and you put it onto the blockchain, thereby reducing the cost of adding information to the blockchain.
Great. Like two last questions. So the last but one is, how does, so like we all have understood now at least, like Matic is a solution to Ethereum and Ethereum's scalability issues.
Right.
So people have understood like Matic is the solution wherein we can, build up decentralized applications wherein we don't have to worry about the scalability. These days we have been seeing that transaction fee for Ethereum is on its peak.
It's pretty crazy.
And yeah. So how so like audience here wants to know how exactly is Matic solving this problem? So they have heard some words like plasma. So would you want to describe much like detailed on it?
Sure. So Plasma is a scaling sort of a solution which was proposed when we first saw Ethereum scaling problems with the aftermath of what happened with CryptoKitties, etc. And essentially how Plasma works is that you have the Ethereum main chain, right? And then you create a chain which is parallel to the main chain. The chain which is parallel to the main chain, so let's call it a side chain, essentially allows you that layer of flexibility. And in this sidechain, you are free to choose whatever consensus mechanism you would like to use. So for example, the Ethereum main chain currently uses proof of work, which is very expensive. We use proof of stake. At the same time, whenever, let's say after every 10 minutes or so every about 250 odd blocks, we take again a Merkle root of all of those blocks and we commit that onto the main chain. Right. So instead of waiting for the main, so instead of having so essentially what you're doing is you're taking 250 blocks worth of information or worth of transactions, and you're creating one piece of data and you're putting that onto the main chain. So you greatly, number one, reduce the cost. At the same time, you can put a lot more of these transactions onto the main chain. And even if the main chain, so here, so it's like this. If the main chain, let's say, commits one block or can do, let's say, 1,000 blocks in terms of transactions per second. Let's say if we can do 1,000 transactions per second, we're doing every 250 blocks. So our TPS becomes 250,000, right? So obviously the math is not exactly this simple, since there is some block time on sort of, putting transactions onto the side chain as well. But so this is how it's also scalability. So we enforce a high degree of security using proof of stake and a large decentralized pool of validators. After every 250 blocks, so every about 10 minutes or so, we create a Merkle root and we commit that onto the main chain. So everything you do on the side chain is committed onto the main chain, and thereby is like super secure. So that's how sort of Plasma works. I'd encourage you to read more about it so you can understand some of the technical points as well. But this is sort of just a brief overview of how the scalability comes into the picture.
Great. Thanks, Ayush. One last question, as I mentioned, was since we have most of the audience who are beginners,
right?
So these are the guys, who are in their BTech or who are, like somewhat enrolled in any kind of a science program or a computer program, be it BCA, MC, etc. And they have some background in the science. So, like for last 3 to 4 years, specifically in India, we have seen a huge trend of artificial intelligence and machine learning. We have seen lots and lots of developers actually been moving there. So, and we are still, like I would say, if not we are not exactly at the nascent stage. We are at the early stages of blockchain adoption in India amongst developers. So, what according to you would be a roadmap for any developer? How can they start learning this particular technology called blockchain? What are the languages or tools which are important for them? And like, what is the future? Let's say if they are investing 1 year or 2 year of theirs during the college, what is the future of blockchain in India? do you think will we have career aspects in terms of blockchain opportunities? Will the companies rise? What would be the job pay, etc.? So this is kind of just a roadmap and a
Got it.
career overview
Got it.
for students. Thanks.
Sure thing, definitely. So there are a couple of ways of looking at this. So let's just start, question by question. So how do you first of all get hands-on with this technology? So like I said, you can check out the developer documentation on our Matic website. I think we have material right from the very basics of blockchain to developing, sort of complex decentralized applications. So I think the developer resources which we have are a great place to start to learn about how blockchain technology works if you're a complete beginner. And I was reading some of the comments. I realized that we did get a bit technical in the middle, so apologies for that. And we'll make sure that in the next session we'll sort of keep it a lot more simpler and sort of reduce the amount of code etc involved. So I do apologize for that. But however, that being said, now in terms of what the future of blockchain holds, definitely we're at the nascent stages. I think even globally, many companies are still trying to figure out how this technology has to work, how decentralized interfaces really well with centralized systems, which we currently have. Um, so I think an easy way of trying to sort of understand or rather think about decentralized technology again without getting too philosophical is okay. Let me put it this way. So decentralized or decentralization or distributed decentralized computing, what it does is that it takes data, right, and puts the power of data into your hands. So this is kind of the fundamental difference between how a centralized and the decentralized system works. So what happens in centralized world, the world which we live in today, is that if you have if you know something, for example, if you know, let's say, if you know some piece of information, right, currently the way the world works is that there is value in not sharing it or not telling anyone about it. Right. So, and this is what we typically call in many ways intellectual property, right? So if I know information and I keep it to myself and I create something what is called information asymmetry, where I know something and you don't, there is value, right? So whenever I know something you don't, I'm able to sort of make more money or create more value. And this is kind of the problem with centralized systems. So centralized systems sort of incentivize you for not sharing or not being a part of the community, right? Which is why when you can make, whenever you create applications which are not open source, right, where the code is a black box, you can make money. Like for example, Google search algorithm is a black box, nobody knows how it works, right? And so thereby Google is allowed, sort of allows is sort of highest in the food chain when it comes to search engines, and they're able to make money. And that's how all of the centralized world works. You make money by not telling people your secret sauce. So this is how a centralized system works. However, the way a decentralized system works is entirely different. In a decentralized world,
Not sure if we are able to hear you, Arjun. Puneet, can you hear him?
No, Ayush. I think there's some network glitch from his side.
Yeah. So meanwhile, I'll take a stab at the question as well from a developer perspective scenario. So from like if I have to go deep down into development aspect and how one can start learning blockchain, the fundamentals are very essential to like to firstly grasp the concept of cryptography and to be able to understand the Merkle proofs, the Merkle roots we are talking about, the Merkle tree, how is a public key and a private key is getting generated. So all those aspects are very fundamental to how blockchain works, right? So how when you save a file on IPFS and how a transaction is executed, there are hashes that are getting generated. So like you got to understand the asymmetric and the symmetric part a little. And on that, once you are in the hold of it, that's when Solidity comes in play. Solidity is a language that is required to learn to basically write contracts, and it's very similar to JavaScript. So, like I was mentioning, there are only a couple of constructs which are there. Uh, so,
right?
sorry, Arjun.
Yeah, man, I think I was saying things which should never be said. So the internet connection had an outage. No, I'm kidding. No, but like I was saying, there are fundamental differences in the way centralized and decentralized systems work, and that's sort of, it'll take a while for people to sort of interface the decentralized world with the centralized world. But that doesn't mean that already massive value cannot be created. So, for example, in cases of supply chain, in cases of governance, in cases of cases where transparency actually creates value, is kind of where blockchain is most efficient. And there are cases in the world we live in where transparency does not create value. For example, like I said, proprietary things like if you have IP or something allow you to make money in the centralized world. So that's possibly where blockchain is not a great fit. But in cases where transparency creates value, like supply chain governance, etc., then blockchain is a great fit. Sorry, Ayush. And of course, if you want to know more about career prospects, Ayush is the perfect person to guide you, since he's also kind of a recent grad. So yeah, over to you, Ayush.
So coming back to what I was explaining, like from understanding Solidity to be able to write the smart contracts, and then getting hold of little wallets experience, right? We have MetaMask, which is generally not the case in traditional system, right? So why do we even need a plugin? What exactly is that plugin allowing us to do, right? So there are different aspects. Just like learning Solidity just allows you to write the smart contracts, but then how you interact with the contracts and why is it even required, why are those wallets required, that's where like a learning curve is established, and it takes like I think it has become super easy like now. When you get on like Google and you write like how to get or how to like get good courses, even matic documentation for that matter, like now the documentation is pretty comprehensive, so you would not really find like yourself drowning and not be able to swim. That's how I started learning. And coming to like career prospects, I believe that's where like that's it's like the environment or the industry you would want to get into. Like every now and then we are getting to hear from different enterprises as well that they would want to get started and they would want to build their applications on public like matic network. And that's when like we do realize that blockchain is going to come in every stage, every industry, be it supply chain, be it like whatever industry you are in. Trust me, like coming from a developer background myself, I think there is no like it's endless opportunities out there in blockchain industry. So
Oh,
yeah.
definitely. Yeah. And any place, any sort of system which relies on transparency to create value between multiple third parties, where problems of trust have to be solved, that's where blockchain is like an automatic fit. So all of these third party problems where there are a number of people who need to interact with each other, transact with each other, that's kind of where blockchain can create massive amounts of value. And just like how Ayush was saying, several large enterprises have recognized this. Almost everybody runs some sort of a blockchain program. Many of them have reached out to us. We've got connected with many people in the industry who are sort of asking us questions now. Okay, how do we use this technology? How do we monetize it? How do we use it to solve problems? So I think the revolution of decentralization is coming, possibly in a couple of years, especially since over the last couple of years we've solved for things like scalability, where layer 2 networks like Matic have solved many of the other teething problems with the 1.0 sort of blockchain implementations. I think we're going to see a huge wave of applications coming. And of course, like I said, our focus is always on creating valuable applications, solving problems for the user. I think a lot of the blockchain ecosystem focuses on cryptocurrency and the value of your currency, and everybody's talking about the $1 million banga and all of that. That's fine, but that's not the long term play. Long term play is to create value. So, yeah.
Yep, great. Yeah. Thanks, Ayush and Arjun, for explaining, for the beginners. I think they're already liking it a lot, and the entire spam is being flooded up. The chat is being flooded up with, thanks for this particular information. So,
Perfect.
thank you guys. Thank you, and for conducting this particular amazing session on blockchain. So, moving forward, guys, we have Joe from Blockstack. So, he's with us here. Yeah. Hi, Joe.
Hey there, everyone.
Great. Good to see you, Joe. So, guys, like Joe is here from Blockstack, and he would be helping us understand what exactly Clarity is, which is a smart contract language on Blockstack, and he'll be helping you understand how exactly you can build, applications on Blockstack and how you can write contracts using Clarity. Also, do not forget to use hashtag Letcon. We would want to see your posts of this session or all the sessions that we have been organizing. Just take a picture of it, take a picture of your setup, take a picture of the notes that you're writing. Just write, yeah, and just write about your learnings from this particular workshop. Post it on the social media, and we have lots and lots of prizes for the same. Also, for the workshop with Joe, so we do have an assessment for it, which would be used to get a certificate. So if you want a certificate on blockchain for this workshop, do listen to it actively, do take notes out of it. We'll be having an assessment, and post that assessment you would be able to get your certificates. The entire detailed process for it would be told to you by the community members on 22nd of August. So all yours, Joe. Thank you for joining in, and looking forward for your session.
Thanks a lot. Appreciate the intro. Hey, everyone. I'm Joe Bender. I was really happy to see the last session was a little bit about blockchain. So you guys kind of got a blockchain icebreaker there, and we can dive right in. Let me share my screen. Okay. Present. Nice. I think you guys can see that. It looks like you can. Really happy to be here at Letcon. This is a stellar event. A lot of great speakers here, a lot of focus on emerging technologies. So excited to bring my favorite emerging technology, blockchain, to the table today, and tell you guys a little bit about specifically what Blockstack is doing in relation to blockchain. We think we're doing some pretty novel, unique stuff in the space. Some cryptographic magic that hasn't really been tried out yet. So really excited to just get it in front of new people, new communities like yourself, and do some education, some good old education out there. My name is Joe Bender. Once again, I am a developer evangelist at Blockstack. I've been at Blockstack for about 4, almost 5 months. So really starting to take the training wheels off. Spent the first few months just really learning as much as I could about our technology stack and our products that we're offering. And since I'm a developer evangelist, my number one focus is getting out into the community, empowering developers to build powerful tools or useful applications that people can interact with Blockstack with. My favorite quarantine activity was definitely browsing Bitcoin memes. The crypto markets have been pretty crazy the last few weeks, and it's always a time of exciting memes and passionate Twitter tweet storms. And there's never a more exciting time to be in crypto than when things are getting interesting. I see my meme is my formatting might be a little messed up. During this talk, I'm going to kind of give you a 10,000-foot view of Blockstack, intro to Web 3.0, what a lot of people are calling this new internet paradigm enabled by blockchain. Give you a little intro to Blockstack and what we're all about. Talk about the Stacks 2.0 blockchain, which is our personal blockchain, and the Clarity smart contracts that are written on that blockchain. And then I'll tell you a little bit of how you can get involved, some of our happenings going on right now, hackathons, events, town halls. There's always something going on in Blockstack land. So since this is a pretty general audience, you guys may not be blockchain experts, but you might also not be completely ignorant of the technology. You might have heard a little bit about blockchain, rumors of Bitcoin somewhere. So I just wanted to overview Web3 a little bit. A simple Google search on Web3 can reveal that nobody really knows what Web3 is tangibly. You know, you look at this image and it's like, oh, Web3 is connecting multiple devices, or Web3 is an iPad, or Web3 means you have your brain and your eyeballs connected to the computer. Web3 is a really buzzwordy terminology for just the new era of the internet. There was kind of Web 1.0, which was super early internet, built by the military. You're doing everything in command line. It's kind of just a pure network of connected machines. Web 2.0 is the internet we've come to love and cherish. Going on social media sites, checking your Facebook, going on YouTube, consuming videos, posting images on Flickr. Who uses Flickr anymore, right? Just interacting with other people and using content and digesting content. So what is Web 3, Well, Web 3 is like a transition to decentralization away from big corporations kind of controlling all the sites. And I love to talk about early internet decentralization a little bit because the decentralized web kind of already existed in a certain form way back in the day. Anyone that loved to pirate music back in middle school and high school is probably familiar with some of these products. The classic LimeWire or Kazaa or Napster were really early P2P file sharing protocols that was very similar to blockchain in the sense that it's a decentralized network. It's a protocol. It can't be shut down. And it's allowing people to share files or data without an intermediary, which is the goal of decentralization. So many of our just societal processes and everyday life interactions have an intermediary kind of cemented in the middle. If you want to watch TV, Netflix is putting itself in between the content and you. If you want to listen to music, Spotify is the intermediary between artists and the listeners. So many structures in society today have a big rent-seeking intermediary in the middle. And rent-seeking is when you are taking a fee or taking a profit, and you're not actually really contributing anything tangible to the process. So, Spotify may be a great aggregator at getting playlists together and showing you new music every Friday and giving you that customized playlist. Spotify isn't creating any music. Spotify isn't an artist. It is purely an intermediary used in distribution. So you can see here, the original internet was literally just wires and network. What was it called? ARPANET or ARPANET or something, created by the military, used to just connect computers into a network so they could talk to each other and send data or messages. Then Web 1.0 came around, and that was kind of the dot-com boom of the late 90s, early thousands. Where you saw pets.com and all those old cringy videos of Jeff Bezos in his tiny shoebox office walking around the Amazon headquarters way back in the day when they only sold books. In America Online, I shamelessly have to disclose I still have my AOL email address just because my mom was a super early adopter of the internet because she owned a business, and I've had an AOL email address since the beginning. Don't worry, it's not my primary. I kind of use it just to sign up for new newsletters that I'm not sure about, and it's kind of my spam email address. But just goes to show the pervasiveness of AOL in the early days, having that desktop application, forcing users to go in there. What else? Google started back then. E-Trade. It's so funny. There were all these first movers that cornered a certain category of the market. E-Trade was all about stocks and trading, and pets.com was about pet food and supplies, and AOL was all about email and chat rooms. Google all about search. This is the era where a lot of the major players of today emerged. Web 2.0, like I said, that's the internet we know and love. You see a lot of familiar sites in there: Reddit, Pinterest, Stack Overflow, YouTube, Netflix, PayPal. This is when the big internet giants really cemented themselves and kind of opened these amusement parks for people to come in and play, such as a social media network or a music streaming service or a professional resume handler, stuff like that. Now, as you can see, things gravitate up towards Web3 here. I said that early internet had a good vision. It was like, okay, we have an internet protocol, TCP/IP, and we're going to have a decentralized network, and then we're going to use DNS to make URLs, and people can access our websites. But somewhere along the way, things got muddy, and centralized. These massive corporations started to get a lot of users, Facebook, MySpace back in the day, Reddit, Twitter, all of these social media platforms started to gain a huge network effect. And that gave them immense power and access to the data and information that the customers are sharing with the platform. Now, when TV started to die out and television advertising, newspaper advertising, you go to the movies, before the movie plays, there's advertisements for new movies. When that started to die down a bit, that kind of blatant advertising, you're being advertised to when you're watching a commercial, that started to become less and less effective because people were consuming media on the internet or streaming from Netflix. So that's when the entire architecture of the internet kind of changed from being a decentralized peer-to-peer network to kind of being a shopping mall that people are going into and then visiting boutiques and certain stores. And when you are in that store, you're playing on their turf. You can only buy their products. You're only interacting with their moderators and employees. And that means that advertising shifted to the internet, to headers, to sidebars, to ads before YouTube videos. And that's where the big grinding centralized machine emerged, where since these social media platforms have large amounts of users, they're harvesting data from the users. And a lot of the times the products are free. Facebook is free. YouTube is free. And while that may seem innocuous at first glance, oh, look at this free program that I can use now and it enriches my life. I can now listen to music easily or watch cool videos. That data that you contributed is now being sold off to advertisers. So not only is your data being sold without your consent and without your compensation, data selling can be okay. People have data to sell, but they're not being fairly compensated for it and being paid in a certain denomination for contributing their personal information. Not only is it bad in that sense where you have no say in it, but then it's being used against you in a hyper-targeted, particular way. Now these companies know your hobbies, your interests, your tendencies, your habits, when you're vulnerable to buying something, when you're not, and they are using that against you in a campaign of making you want things that you didn't know or think that you wanted. Now, a lot of people say, I don't have anything to hide, that's okay. I don't care. They immediately get defensive. And that's such a lowest hanging fruit argument. You don't have anything to hide until you do. We just read a story about two Chinese exchange students who just recently went back to China after being in the United States for a long time. And they were immediately detained for tweets that they had written while in the United States, questioning the methods and morals of the Chinese government. And that's just a perfect example of how one day you're just writing something on Twitter and the next your government is detaining you because of the content that was in the messages that you sent. You have the right to in the United States at least say what you think and not be persecuted for sharing ideas or opinions. The surveillance state that the Web 2.0 internet established is the perfect storm for corporations, governments, nation states, organizations to monitor you and to harvest your data and use it against you. So with all that in mind, that's kind of the why behind blockchain and decentralization. Why do we want to gravitate away from Web 2.0 and these big centralized servers holding all your data at Facebook or Google? It's because we want to empower the individual to take control of their own data, control their self-sovereign identity, I equate it to when you go to a bar and a bouncer is there and asks for your ID. They look down at that ID, and all they need to see is your age. All they need to know is that you are of the legal drinking level to consume alcohol. But by looking at that ID, that bouncer is now getting your home address, your sex, your driver's license number, your height, your eye color. They're getting an entire profile of your life and your very personal details just by looking at your ID. And that's kind of how Web 2 and the hope for Web 3 works. In Web 2, right now, you're handing your ID to all of these sites, Facebook, Netflix, and they are getting everything. They're getting all your data, all your private information, your email address, your phone number, where you live, your watching habits. All they really need is, I don't even know how much it is at this point, $20 a month to allow you to use the service. Let's use Netflix, for example. All Netflix needs is $20 from you a month to continue to use your service. But what they're doing is harvesting your watch habits, your email address, your credit card number, your name, your friends, what they're watching. They're constructing a map of your friend group's favorite shows and the times that you're watching and who you're watching with, all of these relational information that gives a lot of like secret insight into your life and your schedule. And that can be dangerous for a lot of reasons, for advertisers being able to spoon feed you products that are kind of tricking you into wanting them in a sense. And just as Munib Ali, the co-founder of Blockstack, said, no company on the internet should have so much power that they get to debate if they should be evil today or not. And this is all in reference to the Blockstack logo slogan and the Google slogan. The Google slogan for a long time was "Don't be evil." It was "Don't be evil," and it was kind of a stab at some other internet companies like Facebook. That's like harvesting. Facebook is one of the largest aggressors when it comes to using your data and selling it to advertisers. But Google had a slogan that said, "Don't be evil." And it was they were making the decision to not use their technology for evil, not use their search engine. We don't want to be evil. The Blockstack slogan is "Can't be evil," because we don't even have the ability to be evil. The technology and the decentralized nature of our network doesn't allow for Blockstack to have hegemonic control over the network or unilateral decision-making power. We've set it up so we cannot be evil, which we think is a lot better than just choosing not to be evil, because you never know if one day you might want to be evil. And I think that's kind of what happened with Google. When they were a smaller company, just focused on search, they said, we don't want to be evil. We're not going to secretly put items higher in the SEO than they should be just because they paid us money, stuff like that. But as they evolved and became one of the most ubiquitous companies on the planet, every time someone uses the internet, they're interacting with Google probably in some way, whether it be Google Cloud Services or domain names or actually searching through Google. They kind of, as they grew, I'm sure they made the decision to keep compromising and sacrificing parts of their ethos when it comes to privacy and security and not abusing your users' information. So how do we enforce decentralization? We've kind of laid the groundwork for why we need decentralization, why it's important, what happens when there isn't decentralization. Now we need to think, what tools can we use to enforce decentralization and how can we achieve it? And that is with blockchain, which is why I'm here, why my session and the session beforehand, we are so excited about blockchain technology. And why do we care about blockchain technologies? Now, this is a pretty rudimentary section. I'm just going to give a little rundown for those that may not have dove into the blockchain swimming pool yet, give you some basic knowledge about what they are, what they do, and why they're so important. A blockchain allows for trustless transactions between multiple parties. So like I said before, it removes that intermediary. Let's say you wanted to write a will for a will and testament to bestow a trust fund to your grandkids or something. In the real world, you would need a lawyer to write the will, a bank to escrow the funds and manage disbursement to the beneficiary, and then you'd need more lawyers to write the rules for when the beneficiary is allowed to receive funds. All of these can be done in smart contracts on the blockchain and done trustlessly without an intermediary. So in that situation, it's removing 2 lawyers and a bank, which could incur a lot of fees. You know, these financial services sometimes take a lot of fees or commission. And if you're trying to give a trust fund to your grandkids, by the time all those fees get taken out, the trust fund is probably starting to dwindle a little bit. And yes, more importantly, it allows for transactions without the trust of a third-party intermediary, one of those rent seekers that's putting themselves somewhere in the value transmission process. A blockchain, okay, here we go, back to square one for those blockchain beginners. It is just a distributed ledger. You know what a ledger is? It's just a list of items. And a distributed ledger is a list of items that isn't controlled by a single person. It's controlled by a lot of people. Now, that would have been really difficult before electricity or the internet because you didn't have a way to communicate over long distances. The internet and computers gave us the ability to put that operation onto a computer and then distribute it by having lots of computers uphold this ledger. And so how are we getting all of the ledgers on all of these different computers to say the same thing? You know, if you have one computer saying Alice paid Bob $10, but then another computer saying Alice paid Bob 20 computers, 20 something, how do we know which one is right and which one is valid? That's where consensus comes into play. Consensus is the process of lots of different computers talking to each other and achieving a single shared state. Pardon me, gonna have to get this little bugger out of here. So a blockchain is just a list of items, a list of transactions that a set of computers, a network, is agreeing upon using a consensus mechanism. Now, the list of transactions are done between accounts. Accounts are almost like the wallet on blockchain. It's what you are controlling. And these transactions are put into blocks, and that's why it's called a blockchain. In that, sorry, got an attacking cat here. So what a blockchain is instead of just having a long list of items of transactions in that ledger, it has to be broken up in some way so that at each interval, all of the nodes in the network can say, yep, I check off on that. That is a good block. And then you move on to the next block. So a blockchain is just a bunch of blocks, boom, 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 connected to each other. And then in those blocks are a bunch of transactions between nodes in the network. So let's say this network is 4 people. It's Bob, Alice, Joe, and Mary. So Bob pays Joe, Joe pays Mary, Mary pays Bob. Let's say Bob just adds a little bit more to his wallet on his own, blah, blah, blah. All of those actions and operations are bundled into a block. And then once that block is locked, all those transactions get added to the blockchain's history, the historical record. Each one of these nodes in the network is keeping an entire history of that ledger and all of the transactions that happened within it. And so nodes are using an agreed upon protocol, that's that consensus mechanism, to reach a single shared state before moving on to the next block. And then new blocks are just appended onto the last one. And there's some special computer science magic that happens where the next block is pointing to the previous one and also pointing to the next one. That's the chain aspect of it. And it just helps track the transaction history all the way back to the very first block in the blockchain called the Genesis block. So every full node in the blockchain has a whole entire history of this ledger. You can see here it's outlined a little more. A simple transaction can occur on the blockchain between two accounts, account A, account B, send 10 tokens. That's what a single transaction could look like. As I said, a blockchain is just a list of transactions grouped into blocks. You can see on the right side, it's like zoomed in on a block. It has 3 transactions within it. It's also pointing to the last block, 99, and will the next block, block 101, will point to this block. Now, blocks contain an indeterminate number of transactions, depending on how high traffic the network is at that moment. If the network's super clogged and there's a bunch of transactions happening, it's a really busy day, then the blocks might be fuller. If it's a slow day, then there's no need for blocks to wait to be full or anything. And as I said, blocks are chained together. You can see here, this blockchain is at block height 100 right now, which means it's reached 100 blocks. We say height for how tall the blockchain stretches. And each block is created with a pointer to the previous block. I wanted to touch one more time on what this is enabling. Companies like Google, Facebook, and Amazon have gained monopoly power, and it enables them to control and abuse user data, sell it to advertisers, use it to inform feature updates or different functionality. You can force a lock-in or lock people out of their accounts. I know there's been a huge dialogue on Twitter about people getting their accounts banned for having to do with crypto. A lot of companies are just straight up banning accounts associated with crypto. I had a newsletter at one point called Crypto Twitter Roundup. It was summarizing all the biggest crypto Twitter events from the week, and it was hosted on Substack, the newsletter platform Substack. And my account and newsletter and all my drafts and all my hard work I had put in just got completely destroyed one day when Substack decided, you are a crypto-related newsletter. We are going to straight up ban you because we don't want to be associated with the scammy space that is crypto. These companies have like a really ignorant view of blockchain and its potential and what it does. A lot of the times they associate it with the dark web or these big crypto scams. Recently, there was that massive Twitter hack with Joe Biden and Elon Musk and everyone putting out a Bitcoin donation address. They have immense power when it comes to locking people out of their accounts. They can also censor user data and buy up competition. These massive corporations are motivated by profits. They are legally obligated to serve a board of directors and a board of trustees and their investors that bought their stock. So they are not looking out for your best interests and your security and privacy. They want to maximize their profit. At Blockstack, we'll talk a little bit about what Blockstack's doing now. We are building the tools needed for a user-owned internet. We think the internet is a decentralized infrastructure that should be owned by the people. And we are building the tools that hopefully will enable the migration from Web 2.0 land into this new utopia of Web 3.0, where users have power and are interacting with value natively in the network. So Blockstack, it's an open source effort. Everything we do is open source. And we just want to develop software that provides an alternative to Web 2.0. We develop a full stack decentralized computing network, Blockstack ID login, the Stacks 2.0 blockchain, the Clarity programming language, Gaia storage hubs. We really offer it all to usher in a new generation of applications where users are interacting fairly and securely and privately instead of getting their data harvested by Facebook at every click. And we just really want to return digital rights back to consumers and give them the power instead of the unidirectional Netflix and Spotify kind of controlling all your interactions with the platform. So what I want to talk about today is Stacks 2.0. It's kind of the culmination of all things Blockstack over the last few years. Blockstack is actually, in blockchain terms, an old geezer. You know, we got some arthritis in our back. We've been around so long. In blockchain, you see these projects spring up and fizzle out over the span of a year, a couple months, or they launch straight to mainnet. And just last weekend, we saw that YAM, a project on Ethereum, get over $500 million locked in it and then blow up due to a vulnerability. That project existed for a weekend. Blockstack has existed for over 5 years, almost since the advent of all this blockchain craziness. You know, Bitcoin existed for a long time, kind of by itself. But right as new coins started to happen and the ecosystem really exploded, Blockstack was there on the scene. Our CEO and founder, Munib Ali, took a long time observing all of these other protocols, writing down pros and cons, looking at design frameworks and principles, and seeing what worked and what didn't. And, you know, we wanted to take the best of all worlds and the pros from all of the different blockchains and eliminate the cons. You know, you saw Bitcoin be a powerful proof of work blockchain, stay super simple, not have a crazy programming language, and it gained mainstream attention that way. It is a store value digital gold. It's a household name. People know it. And that worked. We also saw Ethereum do super well by adding a Turing complete smart contract programming language. Bitcoin lacked some of those expressive features to build full dApps and decentralized applications and smart contracts. So since there was a need, Ethereum arose and filled that need and gave a lot of developers a home to build more crazy projects and tinker with more ideas like DAOs or dApps or DeFi or prediction markets or Blockjack, you know, blockchain, Blackjack, and all these cool little projects. But we saw that proof of work consensus mechanism really struggle. You know, the gas fees right now have never been higher on Ethereum. It's almost like cringeworthy to send a transaction right now because your gas fees are so high. We also saw a lot of uncertainty there with the switch over to proof of stake from proof of work. It's been in development for a long time. There's a lot of uncertainty with founders. Should we build our app on Ethereum 1.0? Should we build our app on Ethereum 2.0? And you've seen other proof of stake networks be very successful, Tezos and other different types of consensus mechanisms other than just proof of work. So Munib got his binoculars and looked at all those protocols, and we think we have an awesome like patchwork quilt using all of the best parts from the other blockchains. Excuse me one moment. Talking a million miles a minute, I need some water. So we have a couple affirmations here. We believe that Web3 will introduce true internet ownership. We really believe that we're about to transition to the next era of the internet and things are going to get better. You know, people are opening their eyes to the privacy transgressions done by corporations and realizing that the technology is here now to enable self-sovereign identity and to enable people to be their own bank and control their own finances. But we think it's going to be anchored to the most secure blockchain, and that's Bitcoin. You know, a lot of blockchains have spun up recently trying to alleviate some of the issues with the lack of expressive functionality on Bitcoin or the problems with proof of work and its electricity consumption and stuff. But Bitcoin is here to stay. It's the king of the hill. It's a store of value, digital gold. It's on Silicon Valley on HBO. It's on Subway graffiti with a QR code for Bitcoin donations. Bitcoin is kind of everywhere. And we think that the new Web 3.0 should be anchored to it. So Stacks 2.0 represents the design, the blueprint by which Web3 can emerge and scale and have expressive applications and dApps and all that crypto economic fun. but also be anchored to Bitcoin. We think that's the perfect storm there, having all of the decentralized applications of Ethereum, but be leveraging the network effect and security and scalability and just establishment of Bitcoin. Stacks 2.0 was designed with security, scalability, and speed in mind, that triple threat right there. You may be saying, hey, Joe, you just said spinning up a new blockchain isn't a good idea. You should be using Bitcoin. Why did you spin up Stacks 2.0? And that's when you need to pop the hood on Stacks 2.0 and look at the engine inside, because that is leveraging Bitcoin in a totally novel way that we think is going to alleviate a lot of the bootstrapping problems with a new network. What happens in Stacks 2.0 is our consensus mechanism is called proof of transfer. You know, there's proof of work where you're expending electricity or computing power to compete to mine a block. There's proof of stake where you're locking up a certain amount of tokens that are native on that network. Stacks 1.0 used proof of burn, where to compete to mine a block, you were sending Bitcoin to an invalid burn address, and that would lock up the Bitcoin forever. It's unusable, but it would signal your participation in the Stacks 1.0 network. That was cool and used Bitcoin and leveraged the security of Bitcoin, but you never want to be destroying value and destroying tokens and locking up Bitcoin so it can never be used again. Therefore, proof of transfer was born. And instead of sending Bitcoin to a burn address, you're transferring Bitcoin to a certain address that is then rewarded to stackers. And that's where stacking comes in. Stacking is a totally novel value transfer mechanism that allows Stacks holders to earn Bitcoin for actively participating in consensus. So stackers have a bunch of Stacks tokens, and they got some to spare, so they're locking up a certain amount of it on the blockchain. What does that do? It increases security because there's more value in the network. It also incentivizes more people to join the network because there's value in it. So by locking up your stacks and signaling support and not being able to access them for a certain amount of time, you should be fairly compensated with Bitcoin for your participation. Where's that Bitcoin coming from? It's coming from the miners. And that is the beautiful interplay between like Bitcoin, stacks, miners, and stackers. Miners want to compete to lead a stacks block, so they are sending Bitcoin to stackers, and stackers are locking up their stacks because they want to participate in the ecosystem. And that's kind of the interplay between stacking and proof of transfer. Mainnet launch scheduled sometime. We're firm believers in not launching something until it is 100% finished. And that's why we are in testnet right now. We're currently in the Argon phase of the testnet. We started off with Neon. The Neon phase was just connecting nodes. Argon added the mining functionality. And then the Krypton phase, which is coming very soon in the next couple weeks, adds that proof of transfer mechanism. Right now, Stacks 2.0 is still using proof of burn, but soon we're implementing that proof of transfer, and we're so excited to see the community dive into it and start sending Bitcoin to compete to mine a block, and stackers locking up their testnet stacks and receiving Bitcoin for it. It's going to be a really exciting upgrade for the testnet. So mainnet is coming after Krypton sometime, probably 2020, say October, November, December. But we want to make sure it is 100% flawless and ready to go. No bugs, no attack vectors. So when it goes to mainnet, it is just a smoothly operating machine. So you guys might have heard about smart contracts. What are they? Why are they so smart? Smart contracts are just computer programs, lines of code that exist on the blockchain. Like I said, Bitcoin is merely a store of value, can pretty much just transfer it between each other. Other proof of work, other blockchains added smart contract languages, and that allows you to build these smart contracts. And they encode and enforce rules on the blockchain. Just think of it as a file sitting on the blockchain that gets executed when someone sends a transaction to it. Excuse me. So you activate a smart contract by sending a transaction. And apps can take advantage of the smart contracts because it can manage the app's global state. Since blockchains are totally public, anyone can audit a smart contract and look at its code and look at its functionality, which is super important for collaboration. Now, that's a lot of jargon there. What do smart contracts do? Going into some of the use cases can help illuminate and demystify. Access control. Blockchains can help you log into a certain app. If you want to use a decentralized application, you can log in using a smart contract. A non-fungible token. That's been a huge advent in the blockchain era. You might have heard of crypto kitties back in 2017, these little collectible digital kitties. What it does is allows you to put digital assets on the blockchain with a certain set of parameters to them. It could be a piece of digital art. It could be a provably tracked song with the digital rights baked into the blockchain. Non-fungibles kind of blew the space open and really allowed for digital ownership and asset transfer onto the blockchain. And then fungible tokens too, which cannot be, which non-fungible is where every single token is unique. Every crypto kitty is a different kitty. Fungible tokens are where everyone isn't unique. They're all the same. So for example, stable coins, you might have heard of Tether or USDC, Coinbase's stablecoin. These are coins that are pegged to the US dollar. So they try to keep their value at $1, but they're totally interchangeable. It doesn't matter which stablecoin you have. One tether is one tether, regardless of which in the supply that you have. Smart contracts can also enable business model templates such as subscriptions. You could have a smart contract that's deducting a certain fee from your account every month for maybe a music streaming subscription or a magazine subscription. And I'll jump down to DAOs, decentralized autonomous organizations. You might have heard about the DAO in the Ethereum ecosystem a couple years ago. A DAO is just a company that's not run by anyone. It's run by smart contracts in the blockchain. So people contribute a bunch of money to a DAO, and then that DAO has control over what happens. And maybe what happens is controlled by a bunch of people voting with transactions and signaling support for something. A DAO is basically like a company that lives on the blockchain and is just controlled with transactions and value transfer. Super cool stuff. There's a Moloch DAO right now in Ethereum, which is like a funding DAO and a grant DAO. So a lot of maybe philanthropic people or people that just want to see Ethereum grow will contribute a bunch of money to a DAO, and then that DAO votes on what project should receive funding. Mechanisms like that. So I want to talk a little bit about Clarity, and that is Blockstack's smart contract programming language for the Stacks 2.0 blockchain. Ethereum has Solidity to build smart contracts on it. Stacks 2.0 has Clarity. Clarity is a programming language. You write smart contracts. It differs from other smart contract languages, especially Solidity, in the sense that it is interpreted, which means it is human readable and auditable. It is not compiled into like crazy JSON that you're combing through on Etherscan. What you see is what you get, and it makes it super easy to audit. It makes it super easy to work through the lines of code and see exactly what is going to happen. And on that note, it's also decidable and deliberately not Turing complete. Now, Solidity and Ethereum kind of championed the Turing completeness for a long time because that does add a lot of functionality. You can do loops and for statements and all sorts of crazy computer science mechanisms, but there's something called the infinite loop problem, where a program could get stuck in an infinite loop. Let's say you have a variable equals 1, and then you get stuck in a big loop, and the only way you get out of that loop is if the variable doesn't equal 1. But there's no operations being done to it within the loop that's changing the value. So it's just going, if the value equals 1, do this loop, it goes to the end, the value is still 1, so let's do the loop again. That is called an infinite loop, where you get trapped in a certain snippet of code because the conditions for breaking out of it never get reached. That's something that could happen in a Solidity contract, and that is why they implemented gas and gas limits and gas fees. And while that did help solve the halting problem, the infinite loop problem is also called the halting problem because that halts the program. It opened a whole can of worms, and you can see now more than ever how much the gas fees and limits and using gas and solidity, and also thinking about gas as a developer during your development life cycle. It can be a huge pain. So Clarity is decidable. It is not Turing complete. And while that does give you like some slight shortcomings in looping, and there are a lot of workarounds that the community, the Blockstack community, have been collaborating on a lot in the Discord and the forum and stuff. Most of the time, you can find some workaround to do the desired functionality you need, and you didn't need Turing completeness in the first place and the whole Pandora's box that came with it. So in this way, since Clarity is existing on Stacks 2 and the Stacks 2 consensus mechanism is using Bitcoin in cool ways, it's kind of like an ability to write fully expressive smart contracts that anchor to the Bitcoin ecosystem. We have not forsaken Bitcoin world. We heart Bitcoin. Also, Clarity is a strong static type language, and it's Lisp-based for some of you Lisp fans out there. And just like other smart contracts, it's composed of two parts, a data space and a set of functions. The data space is just a little handbag that the smart contract has that it can store data in and information and recall it. And then the set of functions is like the actual smart contract. And like I said, you call smart contracts by sending a transaction. Now, this is getting into a little bit of some dense stuff. I'm going to tear through all these. Some of the vulnerabilities in other smart contract languages are impossible in Clarity, such as the 0x exchange breaking down due to an assembly error. The DAO hack was a big reentrancy attack. The parity multisig, another reentrancy attack. And a lot of transactions aborting because of those compilation or out of gas errors on Ethereum. So I'm going to show you a super basic Clarity smart contract just to reduce some of the intimidation. I know smart contracts can seem scary, and there are big, crazy ones, but most of them are simple and logical and can be walked through. This is a simple counter contract. It's just incrementing and decrementing a certain variable. And we also love test-driven development at Blockstack. So we like to test things. We're going to do these little 4 tests. The 4 tests are, was it successfully deployed? Does it start at 0? Can you do +1? Can you do -1? And you can see up here, we're giving a provider, which is just like a Blockstack address, which you need to deploy the contract, which means the first test would pass. The second test is see if the variable is equal to 0. Oh, you can see my mouse, so I can do some circling. Here you can see, yes, the variable is equal to 0. This next test is it should increment. Oh, this is the test code. This is the real code. Oh, no. Increment, get counter 1, execute method increment. It's executing the 2 increment methods. So the 0 variables turning into 1, turning into 2. And then you use the decrement method, bringing it back down to 1, bringing it back down to 0. So as you can see, this is a super simple program. It would pass all these 4 tests of being able to increment, decrement, and start at 0 and deployed. Yeah. Little contract will bump up the difficulty. This is a tip calculator. You can see it's defining the variables for the meal cost, the tip, and the rating. The one thing I love about this contract is it takes rating into account. If your rating was greater than 3 stars, you're going to tip 20%. And if it was less than 3 stars, you're going to tip 15%. And down here is where all the magic happens. You know, it is a private function, calculate the tip, begin. If the rating is greater than 3, then multiply the meal cost by 20%. If your rating is less than 3, then multiply meal cost by 15%. Super simple smart contract, just calculating a tip. You know, you can do that in your head. Oh, to calculate a tip, I just need to take my total meal cost and then multiply it by the percentage that I think they deserve. Boom, smart contract. So now I want to talk a little bit about our hackathon series. From now until mainnet, it's going to be a non-stop hacking extravaganza. We're cranking out hackathons all the time. When one ends, a new one begins. So don't worry if you're crunched on time, you don't think you can get done with one. But we would love to see all you guys participating in hackathons, checking out the Blockstack ecosystem. We really think we're a good jumping off point for blockchain beginners. We're the only SEC qualified token offering. The Stacks token is the only token the SEC has approved to be launched in the US. So we think we're here to stay. We think we have a novel consensus mechanism, and we would be a great introduction for anyone that wants to learn about blockchain. The first hackathon in the series is the Clarity Hack. It's actually been extended to August 24th, this Monday. I was going to take this whole section out of the presentation, but you do have 4 or 5 days here to throw together a contract if you are so interested. You just saw contracts can be super simple. You know, they don't have to be complicated. So if you're looking to make a little extra money this weekend, definitely check out the Clarity Hackathon. This one is totally focused on smart contracts. You're just writing smart contracts in Clarity. It's open now. It opened on July 29th. Like I said, it's been extended to August 24th at 11:45 p.m. EDT, so close to midnight Eastern time in the US, which means you have a couple days here if you want to try to throw together a contract. Also, we already had a smart contract hackathon back in May. This is like round 2. So there are a lot of Clarity smart contracts already out there on the internet on GitHub for you to tear into. Van Gogh said, great artist steal. Definitely don't plagiarize the whole contract. But, you know, you can use snippets and get ideas or motivation, inspiration from other contracts. I always take a gander at some other contracts before I start whipping up one of my own from the grassroots. There's over $5,000 in prizes. The top few contracts are bringing home big money. It's also hosted on DevPost. If you're familiar with them, they're great at managing hackathons and should just help you get a little friendly with Clarity. We audited all the smart contracts we got in our first hackathon in May, and this is a list of all the ones that were not built and we want to see built in this one. This hackathon is almost like a smart contract safari. We want people to go out and build these ones, and we're also offering $100 bonuses. If you go after one of these contracts and build the best one, you could receive a $100 bonus. This is the judging criteria. Not important if you're not going to participate in the hackathon, but important in the sense that I think it's a great criteria for any smart contract, you know, not judging a hackathon, but just appraising the quality of a smart contract. The design, is it well structured and broken into logical functions? You know, that tip calculator was broken in, or no, the counter program was, there was a method for incrementing, a method for decrementing. You don't want those to be jammed together. You want to separate all the different functionality into different methods. Functionality, how useful is the smart contract? That tip calculator, I go out to eat a lot. I need to calculate tips a lot. That could be super useful in my life. The use of Clarity reference. That one used Clarity a little less. It was so basic. It's literally just using like arithmetic. None of the crazy like mapping and other more complicated stuff in the Clarity documentation. Originality, creativity. This one's pretty important because smart contract languages have been out there. You know, people have been using them, and there's kind of a lowest common denominator of contracts that people already know. You know, escrow contracts or DAO contracts. We really want to see smart contracts that think outside the box and maybe haven't been built before. Real world viability, a little similar to functionality. Like I said, can it be used in real life? Tip calculator, super useful. And then documentation and commenting, every developer's favorite thing to do. We really like to see comprehensive documentation accompanying a lot of the smart contracts to help beginners maybe learn a bit more about it, work through the code. And we also love to see great commenting, descriptive commenting all within the smart contract, which since it's what you see is what you get, having more commenting in there can just add so much context to your smart contract for someone that wasn't there to build it and may not know what all the code does. Simon Cowell and Gordon Ramsay are judging our hackathon, so you really want to get in there. That's not true. They're not. We couldn't get them. They were too expensive. But we have some great Blockstack engineers judging. Like I said, the pricing is through the roof. People get at these prizes. The first place contract is getting $2,000 US. Second, $1,500 US. Third, 1,000. And then you can see we have up to 25 prizes. 4 through 6 are winning 500. 7 through 10 are winning 250. And then the bottom 15 smart contracts are still getting $50. And those will probably look a lot like the tip calculator. And they're super simple and easy to build. So I encourage you all to build some smart contracts in the next 4 days. Also that it's actually a 100. We're going to do 2 $500 bonuses for the bounty hunted desired smart contracts, but I think a lot of people are going to go for those, so we changed it to 10 $100 bonuses. So 10 people are going to be getting bonuses for getting those desired smart contracts built. How to get involved? The link is right there. I can maybe make my presentation available somehow, but if not, just search Clarity Hack Dev Post on Google. Get all signed up there. There's a lot of resources for getting started with Clarity there. A bunch of other sites here. We have the Blockstack forum, the Discord, our GitHub. I'll go through a couple of those now. This is what the hackathon looks like. Super straightforward. Click on the big green button to start your submission. You can see in the resources section, there's a bunch of great community resources for Clarity there. Our community is so amazing. A bunch of rock stars, content producers. They're always putting out demos or tutorials or sharing ideas. Super easy to get inspired by looking at the community resources. And the deadline is not August 14th. It is August 24th. Like I said, you have a couple days to do it. This is the Blockstack Discord. It is your one-stop shop for just hanging out with the community, and there's a hashtag hackathons channel if you are participating in the hackathon specifically. And you can see here 2 of our best community members, Friedger and Harini. Harini built Block Survey. You might have heard of them before. And Friedger is made a lot of the Clarity smart contract boilerplates. If you find a smart contract tutorial, he might have wrote it. And you can see on the right, there's a lot of PBC, Blockstack PBC members in there. And we're actually trying to gravitate completely away from Slack and destroy our Slack and exist mainly on Discord, just because we wanted to be that much closer to the community and feel that much more accessible, be able to be available for questions anytime, or to help hackers during the hackathon, or engineers to help people that are stuck in a certain mining tutorial, stuff like that. This is the Blockstack forum. For you 90s kids, you might like forums more than the architecture of today. I feel like today is ranked lists like Reddit. The most upvoted stuff is at the top. My heart is still attached to the old forum architecture where it's not ranked, it's fully chronological, and it kind of helps you follow conversations more. So the Blockstack forum would be a great place to post if you want a longer description of something, or want people to spend a day or two to brainstorm and then come back with a longer form response. This is the brand new Blockstack docs. I added this slide this morning just because I'm so excited about it. Look at that dark mode. We just updated our documentation. Our DevX team has been laboring the last few weeks to get this done. And it's beautiful, and it is comprehensive and substantial. It has everything you can need to get started with Clarity or Stacks 2.0. Some great tutorials on everything, writing smart contracts, mining Stacks tokens, doing everything with Blockstack technology. It's going to be your one-stop technical shop for learning and educating yourself about our stack. One final shout out here is for our conference happening this weekend is Future Proof, a collaboration between Blockstack and Dystopia Labs. Some of the speakers are blowing me away. We have Elizabeth Stark from Lightning Labs. Munib Ali, our founder, will be giving a talk. I'll be giving a talk on spinning up your own Blockstack node on Sunday. And then Brittany, I forget her last name. It starts with an L, but she was one of the Cambridge Analytica whistleblowers. She will also be speaking at the conference. Blockstack conferences are always popping off. This will be my first one, as I'm only 4 months into my Blockstack journey. But in the past, they've had Edward Snowden, Balaji Srinivasan, some really huge names. Our events people are top notch, and I'm sure this is going to be a very high quality event. Really looking forward to it, and hope to see you guys there. I think that is all I have for you today. Big crash course on Blockstack. Thank you so much to Zubi for having me. I gave a little Zubi workshop last week and was just blown away by the passionate Indian developer community. Looking forward to seeing you guys in the future and encourage you to tinker with some of our stuff.
Great. Thanks, Joe. Thanks for an power-packed session on Blockstack, helping people understand what exactly Blockstack is, and showing them across how to write contracts using Clarity, how easy it is to write contracts, and then explaining about the series of hackathons, the series of prizes, the series of documentations, how they can actually start their journey on Blockstack. It was totally a power-packed session in terms of knowledge, in terms of learning, and I think definitely the people who are watching this conference, the attendees here, would have a lot of resources on how Am I audible, Joe?
A little bit. You were breaking up a tiny bit, but I think I got the gist of it.
Great. Yep. Sorry. I think there's a bad internet connection. Anyways, the chat is being flooded now with people, posting about how amazing this session was.
Thank you guys so much. I really appreciate you having me, letting me sing you the song of my people a little bit. Really excited about Stacks 2.0 and just trying to build a village to build a blockchain. It's not one company. It takes a community.
Of course. So Joe, we have a couple of questions from the audience. So the first question is from Shreya. So it's a basic question. Basically, the question is, what is the language that you're using to develop Blockstack? Like Ethereum has multiple languages. It was started in Golang, then a Python version of it was created, then a CPP version of it was created. What exactly is Blockstack using?
That's a really good question. Let me see. Let's go right to the repo. I'll also post it in the chat. This is, well, maybe I don't have the ability to post a comment.
You can post it on the private chat. I'll share it with them.
Oh, nice. I just wanted to link to our Stacks blockchain repository. Our main blockchain repository that you are downloading to spin up your node. To answer your question, honestly, I don't know. That's our engineering team. I'm not super sure. I know it's a myriad of languages. It's a couple, and we have Clarity.js. We have like a JavaScript SDK, and we just partnered with Algorand to really advance the Clarity language. But yeah, I'm unsure of what the actual infrastructure of the Stacks blockchain is built under and the exact language. But I think that the GitHub repository blockchain client is built in Rust. Yeah, that sounds right. I like it. You do have to download Rust to spin up your node, but it's a myriad of languages. It's built in Rust, but you can use the Clarity.js SDK to build JavaScript stuff. All the smart contracts are done in Clarity. And then some community members have spun up like React packages that are allowing you to build a React front end with a Stacks 2.0 back end. We're trying to be pretty language agnostic.
Amazing. Thanks, Joe, for that question. And the next question is, can you share some insights on proof of transfer, the POX, which Blockstack is using?
Yeah, absolutely. I gave a little overview, but didn't dive super into it. Like I said, we wanted to find a way to leverage Bitcoin and use its security, but also enable decentralized applications. And I mentioned that it does appear like we're spinning up a totally new blockchain, but all of our foundational elements of the blockchain are contingent upon the fact that Bitcoin is safe and operational. The entire mechanism behind proof of transfer is using that Bitcoin by transferring it. So a little more of a technical explanation. I said that miners will transfer Bitcoin to, it used to be in proof of burn, an invalid address, and that Bitcoin would be locked forever. Now, when stackers lock up a certain amount of their stacks token, they also designate a Bitcoin address that they would like to receive rewards in. So miners are transferring Bitcoin to compete to mine a block. The more Bitcoin you transfer, the better chance you have of leading a block. It's just like in proof of stake, the more you stake, the more significant of an actor you are. Or in proof of work, if you have a better GPU, you probably have a better chance of mining a block. In proof of transfer, the more Bitcoin you transfer, the more chance you have of leading the block. And that Bitcoin is getting transferred directly to the stackers' addresses that they signaled. This is my Bitcoin address. I'd like to receive my reward for locking up my stacks tokens here. So that's all done automatically. Super simple. You just run up your mining software on the command line, and then the proof of transfer mechanism, and it has something called a verifiable random function. That's what's making everything fair. You know, picking the leader of the block fairly, and distributing the Bitcoin rewards to stackers fairly. So that Bitcoin is getting transferred directly to all of the stackers. And there's just a crazy incentive structure there. You know, the stackers are incentivized to lock up their tokens because it makes the network more valuable, but they're also receiving BTC awards. And then you could receive a discount on mining by also stacking. So we anticipate a lot of miners will also be stackers. And then the Bitcoin that they are receiving for stacking, they can use right back into mining. And just a beautiful interplay between multiple cryptocurrencies using kind of a novel consensus mechanism.
Great. That was a detailed answer, and definitely that should have helped Imran, who has asked this question, and others who are watching this. The next question is kind of, off topic, wherein we won't much talk about Blockstack, but we want to talk about Joe Bender. We want to know how exactly, you have started your journey on blockchain. What motivated you towards, learning blockchain, and like your journey into this ecosystem?
Absolutely. Wow. I didn't prepare for this, but I have always been interested in technology, as a lot of people our age, like millennial age, are. I'm 27. I grew up playing Math Blasters on my computer, or using Netscape, or like I showed LimeWire and Kazaa. I've always been what's called a digital native. A lot of our parents were digital, I forget what it's called, like digital migrants, where they had to adopt this technology. It was new to them, but we grew up with this technology. So I've always been interested in emerging technologies, and who knows, first blockchain moment, I think it's just friends using Bitcoin in college. But my first was my friend reaching out and saying, you got to check out this thing called Ethereum, and looked into Ethereum and discovered Bitcoin. And it was right when I finished grad school. I'm from Pittsburgh, Pennsylvania, and I threw all my stuff in a car and I drove to New York just because I wanted to be where the crypto world was. And it was super early 2017. And my friend had Joe Lubin's email address, and he gave it to me, and I shot him a cold email saying, I want to join Consensus and work on Ethereum, and the rest was history. I joined Consensus and worked with Joe Lubin for about 3 years. And I mean, if you were in crypto during that time, you know of what a roller coaster it was. It was such an eye-opening, educating experience to be with a crypto company during the bull run, during the big crash, during the advent of DeFi, during all of these exciting times as protocols have come and gone, trends have come and gone. I always say 1 year in blockchain is like 5 years in the real world on your age and your well-being. But what you lose in your physical well-being, you gain in experience up here. Yeah, I just was always interested in the technology. I'd say I've always kind of been somewhat of a crypto anarchist, if you couldn't tell from some of my early presentation. It's just so disheartening to see, my crypto newsletter got shut down on Substack. I've seen so many people's Twitters get shut down just for saying something about crypto, or the Cambridge Analytica thing, the US election, and Facebook accounts and Russian bots. And, the world is a very chaotic place right now, and technology is right in the middle of it. And I think that if we don't start laying the groundwork now for healthy technology and healthy networks, the same thing that happened to the internet is going to happen to a lot of other new emerging technologies. Oculus just announced yesterday that you can't use Oculus Rift without a Facebook account starting next year. I'm a big VR user, and VR is just a hardware that you should be able to use and interact in the VR world. The fact you need a Facebook account to use the $400 piece of equipment you bought is outrageous, and it's just another example of corporations putting themselves in between users and things that they deserve. I think I've been in blockchain for a long time. I think I'll be here for a while. I'm extremely excited about the potential of the technology. I think that there's the grandiose dream of blockchain, the utopian Web 3.0, everyone owning their own data, and then there's the timeline where everything goes to zero and blockchain is forgotten and it's a scrap on the side of the road. I don't think either of those will happen very fast. I don't think we're going to fast forward to the blockchain dream, or I don't think things are going to crash and burn. I think it will be a long uphill battle of building exciting things, experimenting with cool products and technologies, and projects gaining a bunch of attention, projects blowing up, mainstream institutions and banks and governments hopping on board slowly but surely. It's been a roller coaster, but I'm strapped in for every turn on it.
Great. I think this might be inspiring for most of the people, wherein you see ups and downs during your life, but it's not that during the downs you leave a particular technology that you believe in, or you get demotivated due to those activities. We all have seen this. Joe is into blockchain, I think, for more than 4.5 years now. Uh, we at Zubi, most of us are personally believing blockchain. We are working on blockchain for 3+ years individually, wherein we tried and set up a blockchain community focused for students in India. We tried set up a lot of learning resources for them in India, and definitely the journey has been a roller coaster. From specifically in India, wherein you don't have a clear norms in terms of what cryptocurrencies are, and then specifically later on a period wherein a lot of news channels and media companies coming in and saying, the crypto has been banned by RBI, which was kind of a shamming, and then a lot of crypto exchanges got banned in India. A lot of people shut down their businesses, and whole blockchain journey came to a stop.
Yeah.
This was during the period when blockchain was on a hike, wherein the Bitcoin was rolling around $19,000, and those was the time. Yeah, so definitely it has been a roller coaster journey. So, anyways, coming back. So, thanks, Joe. Thank you for all the insights and for your time and helping the students and the attendees of this conference understand what exactly Blockstack is and how they can start, their journey on this particular using this particular platform, and how they can build a cool decentralized applications and smart contracts using Clarity. Thank you, Joe.
Thank you so much. Really appreciate everyone's time and attention. And I'll see you in the blockchain world.
Great. So moving ahead, guys. So now we have come towards the end of this particular day. We would be ending the day one. And before we end, there are a couple of things that we want to announce. So we have had 2 workshops today. One was with Matic, one was with Blockstack. So all of these workshops, so they would be a combined assessment for the workshop on Matic plus Blockstack, wherein you would be asked around 20 to 30 questions, and you will have to take an assessment on it. Post that assessment, if you pass it more than 30 or 35%, you will be getting a certificate for it, right? So the process to get the certificate would be informed on day 3 during the closing ceremony, wherein you can understand how exactly you can claim your certificates, where you want to go or where you have to go and take the assessments, etc. Second thing is, tomorrow we have a fully packed session. We have a lot of interesting thing wherein I'll just share my screen to share the schedule. Yeah, if you can see the screen, great. So day 2 will start tomorrow at 3:15. Post that, we'll have Atul Kekade from Zenfin, who would be talking on how to move from into the next phase of blockchain or decentralized ecosystem in India. That is, now we have heard of blockchain being theoretical. How can we actually implement, and what is the action plan for blockchain in terms of Indian audience? Post that, we have Mrs. Shalaka Verma. She is director of quantum computing at Microsoft. She would be coming and sharing the exponential journey with quantum computing. Post that, we have a fully packed session on augmented reality, which is being taken by Mr. Reni Schult, wherein he would be talking about the current state of the technology and explain why spatial computing with VR, AR, MR, which is mixed reality, is a key to technology and the fourth industry revolution. I could see a lot of questions regarding the fourth industry revolution, regarding integrating quantum computing with other technologies or integrating spatial computing with other technologies. This is the particular session that you'd want to attend to understand how exactly we can do that. Post that, we'll have Miss Louisa Spring, who would be talking on augmented reality, virtual reality in the gaming industry. Due to this COVID-19 and due to this lockdown that we are facing in India and across the globe, a lot of gaming companies are on a rise. You might want to understand, if you want to choose gaming or game development as your career, how AR, VR can actually act or actually add a value to it. How you can build games which can be downloaded by millions of people and played by billions of people. Post that, we have a very interesting workshop by Mr. Ashik Hamid. He would be talking on how to make your own Instagram filter. All of us, I'm sure, we have around 100 plus people watching us live now, and I'm sure 90 plus of them are using Instagram. You use Instagram stories. With that particular workshop, you can understand how you can create your own filters. Wouldn't that be amazing? Post that, we have Sunil David, Mr. Sunil David, who comes from AT&T, and he would talk on Internet of Things, the intelligence unbox, the Internet of Things revolution. He will talk on how Internet of Things would, revolutionize the future. So tomorrow is a day wherein we'll talk about quantum computing, we'll talk about blockchain, we'll talk about Internet of Things, we'll talk about spatial computing, we'll talk on AR, VR, MR. So, all the emerging technologies are going to be covered at a single day tomorrow within 5 hours. So tomorrow being a very interesting day, so you will be getting all the details on how you can join. Most probably the sessions would be same as today as on StreamYard, because there was some connectivity issues with the other platform that we were using. So tomorrow you'll be getting the link to join. You can find the broadcast. You can find the same broadcast on YouTube at our channel, and then you can join it. Make sure you join in on time so that you don't miss any of these sessions. Apart from that, now since we have a lot of prizes, we have prizes for the questions being asked. We have taken a note on people who have asked questions on today's lecture, on today's session, on today's conference at different sessions, and we will be announcing the winners at the closing ceremony. So you will be getting the details on what you have won, how can you claim it, how can you get the certificate for attendance, how can you get the certificate for workshops, all the extra details in next couple of days. So stay excited, guys. Looking forward to seeing you all. Bring in your friends to join us, and thanks for all the support, and really sorry for the inconvenience. I think we are around 40 minutes delay regarding the planned schedule, but tomorrow we definitely will be on time. Thank you, guys. Thank you for joining, and it's been great hosting you all. Thank you.